Morning, Sermon. Mic check po.
Good morning, Dax. Okay ba, audio?
Yes, sir.
Okay.
Okay.
Okay, good morning, everyone. Happy and have a blessed Saturday. May our day be blessed with happiness and peace of mind, and may we be free from all the burdens and know that we are completely cared for. Let angels light our way with grace and have a beautiful, awesome day. Welcome to our third day of our International Virtual Congress and 2022 Philippine Agriculturist Summit. We will be having our second plenary session for this day in connection with the theme Digital Agricultural Science and Technology Directions and Challenges. The plenary session that we will be having now is entitled Analytical Approaches to Address the Science and Technological Challenges of Digital Agriculture. Digital agriculture, according to Anite et al. In 2021, is associated with the socio-technical process of applying digital innovations. In a briefing paper by the Food and Agriculture Organization of the United Nations in 2019, entitled Digital Technologies in Agriculture and Rural Areas, Trendov et al. Reported that the enablers for digital agriculture transformation are the use of digital technologies among rural populations and farmers, digital skills among rural populations, and digital agri-entrepreneurial and innovation culture. Scholars have commenced analyzing the S&T challenges of digital agriculture, have begun to use various analytical approaches, which include, among others, geospatial data analysis, big data and value chain analysis, and a mix of quantitative and qualitative tools. So for this plenary session, our facilitator is Dr. Anastasia Notarte. Good morning, Doc Anna.
Good morning, Sermon. Good morning, everyone, and welcome to the second plenary session of our second PAA International Congress and Agriculturist Summit. Mayong buntag, magandang umaga sa lahat.
Good
Now, in this,
morning.
yeah, good morning. So, in this session, we have four exciting topics. No, but before I will proceed, may I please request our participants to write your question in the chat box. If you have some inquiry right after, so the host or our admin of PAA will write immediately the question and it will be flashed immediately right after the discussion of our speaker. Thank you. Now, for the first presenters that will be discussing the topic entitled Clustering Farm Characteristics for Integration in Rice Crop Managers Fertilizer Recommendation Algorithm using data science methodologies. Now, ladies and gentlemen, our presenters are graduate students from the Master of Science in Data Science at the ASEAN Institute of Management, or AIM. This team of data scientists has diverse experience in banking, agriculture, aviation, real estate, human resources, food and beverages, and power. Now, the members of the team is Widi Dayamada, Deals and Corporate Finance Manager from PwC Philippines, who has executed combined valuation projects of at least 400 billion pesos. Now, the second member of the team is Joanne Alon Pineda, an economist at the Department of Economic Research of the Bangko Sentral ng Pilipinas with 7 years of experience in the department's Economic and Financial Forecasting Group. The third is Ali Fuentebella, the head of finance and chief future officer from the World States International Network and a project leader of multinational conferences of World States International. And the fourth member is Samuelson Sailim, an established mechanical engineer with 7 years worth of combined experience in power generation, aircraft engineering, and building services. Now, ladies and gentlemen, please sit back and relax while we are listening to the team presentation.
Good morning, everyone. Today, we walk you through Project Terra, a data science project dedicated to helping Filipino farmers through an efficient dissemination of fertilizer recommendations. In the next few slides, we present to you the three big ideas of Project Terra. The first big idea is that Project Terra, this data science project, helps more farmers get access to fertilizer recommendations to optimize their yield. Given how important fertilizer recommendations are, the government, together with the International Rice Research Institute, or IRI, developed the Rice Crop Manager, or RCM, to provide farmers with customized fertilizer recommendations based on their farm characteristics. However, currently, RCM's process is resource intensive, where an extension worker needs to interview a farmer for 10 to 15 minutes before RCM can give out a recommendation. With Project Terra, this interview time is significantly reduced to 3 to 8 minutes. So how does Project Terra do this? That can be answered by big idea number two. Big idea number two says that Project Terra uses farm clusters to predict fertilizer recommendations. In other words, the from the 700,000 filtered farmer recommendations in the Philippines, we group them into 7 clusters or groups using data science. These groups were then used to predict the level of fertilizer recommendations, or NPK levels. Lastly, for big idea number three, with Project Terra, the increase in farmers' income in the country is estimated to be at least 400 million pesos. Increase in yield is expected to be at least 22.5 million kilograms after its implementation. We shall discuss later how IRI, our partner in this project, suggested to quantify the business value based on the diagram you see on the screen. All of these big ideas are summarized here. We shall revisit these points again as we conclude the session. Here is the 5-part content of our discussion today. First, we'll discuss the overview of Project Terra. Next, we will deep dive into the phases of the project. After that would be operationalization, business value, and finally, conclusion. We start with the overview of Project Terra. What you are seeing here is the breakdown of production costs of farmers. According to IRI, 15% of production costs of farmers are fertilizer spend. And this share of fertilizer spend is considered significant, given that our farmers earn only around 21,000 pesos per season in 2020. Too much fertilizer would eat up the profits of our dear farmers, while too little could mean foregone income to them due to low yield. Hence, balanced fertilization is important for these farmers because it improves soil fertility, improves crop quality, and also increases farmers' income. But what exactly is balanced fertilization? Balanced fertilization is the application of plant nutrients in optimal amounts of the following macronutrients. N for nitrogen, which promotes rapid plant growth. P or phosphorus, which promotes overall reproduction of the plant. K or potassium, which promotes root development and plant vigor. This is usually taken together as a fertilizer recommendation called the NPK. In this project, this is also the target variable, or the variable that we aim to predict. Considering how important balanced fertilization is, IRI devised the Rice Crop Manager, or RCM, to provide free fertilizer recommendations to our dear farmers. So here is how it works. First, farmers gather in fields or sometimes in barangay halls. Then an extension farmer would interview these farmers through the RCM questionnaire using a tablet or a paper questionnaire. Then the RCM platform would give out NPK fertilizer recommendations. While all of these may look like a simple process, RCM actually met a lot of challenges in the implementation. For one, there's only limited extension workers in the country. Next, the interview process takes around 10 to 15 minutes, which it reviews as inefficient as of the moment. And because of these, RCM is performing below the number of farmers that they target. For the last 2 years, for example, they've only been hitting around two-thirds of the target. With all of these challenges, we have the following problem statement. How may we help streamline farmer interviews for fertilizer recommendations, specifically for RCM? ERI has also put forward that they're also interested to see farm clusters in the analysis. With that, we look into possible related literature. However, similar studies focus on generating acceptable NPK recommendations rather than streamlining operations. Some studies also have variables that are not present in the data, such as soil type, humidity, among others. The most similar study used a KNN algorithm with a 68% precision metric or performance. This is the most similar study because of the variables used and the methodology considered. With these findings, Project Terra aims to address the following gaps in the academic literature. First, that is to improve the prediction through clustering, given that previous similar studies perform below 70%. Next is to localize the study in the Philippines setting based on the available data. And finally, focus on streamlining farmer interview process using less data but acceptable accuracy. Project Terra, this data science project, has 4 phases. The first one is what we call classifying, where we select the variables to be clustered based on the questionnaire. Next is phase 2 or clustering, where we perform the clustering algorithm on selected variables to categorize the farms into clusters. Next, phase 3 is what we call modeling, where we integrate the clusters from phase 2 and other variables into a prediction algorithm. And then finally, phase 4 or training, where we train the staff of ERI on the fundamentals of data science and the use of the new algorithm. In this section, we shall now start discussing the 4 project phases of Project Terra. This shall start with phase 1, which will be discussed by Ali.
We now start discussing the 4 phases of Project Terra. The first phase of Project Terra entails classifying what are the variables of the given data should be clustered or retained. So as a background, the ERI provided us with 2 sources of data. First is the dataset used in the RCM tool to formulate and logically generate the field-specific recommendations to farmers. And second is the dataset collected during farmer interviews, and this is merged with the recommendations data of the RCM tool. These files shall encompass data for the last 8 years, with more than 2 million individual fertilizer recommendations from 2014 to 2021. These data files received from ERI were in the form of Excel files, each representing 1 year of collected data. The data was combined and further processed using Python, and in total, the data contains 2,513,222 data points, where 1 data point is representative of a fertilizer recommendation to a particular farmer, with farm characteristics and variables detailed on each column of the data. So just to give a brief overview, the qualitative and quantitative features of the farm per data point can be categorized as follows: the farm characteristics, the farm practices, the fertilizer recommendation, and the timing of fertilizer application in the farms. These features are housed in a total of 51 variables, and we loop these through 3 iterations along with ERI recommendations to finally come up with our final list of variables for clustering and modeling. In our 3 iterations, we use the following general criteria and technical assessment in selecting the variables to cluster or model. First, clustered variables must be permanent for each farm-like location. Second, for categorical variables, we would want them to have low cardinality or just a few unique values like crops per year, etc., to avoid high dimensionality in the data. Third, variables must not be highly correlated with other variables, and in doing this, we use the PAA metric, which allows measurement of correlation across all categorical, numerical, and ordinal variables. So the figure on the right summarizes the pairwise PK correlation values for the variables. So the darker colors here represent high correlation. Our last criteria is data completeness, as we recognize that those with incomplete data will affect the quality of our data analysis. So data completeness was assessed in terms of the proportion of valid values. The charts represent completeness of the data. Darker colors mean more important complete data, while lighter shades indicate more missing values. So for the predictor variables, the centroid, long lat, the number of organic fertilizer, the previous yield, and all the other rows, they are highly sparse, as can be seen by the flesh-colored rows. This is a crucial step for us because one of the reasons for us to drop variables for clustering is because of the sparsity of data. So all in all, we have removed 31 variables out of the original 51 for the following reasons. First, it is not needed in modeling or clustering. Next, it has missing values. Third, it is redundant with the presence of other variables, or data is already incorporated in other variables. Also, if the data has high sparsity, like it's greater than 58.5%, it will be removed from the data. And lastly, data was added or removed through ERIE recommendation based on project scope. So ERIE's recommendation was crucial in the classification and filtering of our data. For instance, the ERIE team recommended to retain a data feature called seed source, which is only available from 2017 to 2021. As such, 70% of our data is removed, which I'll summarize more later. And another important part of our data analysis is really the alignment with ERIE, that we work on key assumptions that the approach on the usage and analysis of this data is not temporal, and that each of the recommendations will be treated as individual separate farm recommendation data, and it will be processed for this project excluding the temporal aspects of the data collection of ERIE. So given these changes, the revised classification is shown as follows. For the variables that we will use for our phase 2 cluster, we have 7 variables, namely the location, represented by the longitude, latitude, the elevation, the RCM water regime, the RCM water supply status, the RCM crop establishment, the crops per year. For phase 3, we will do modeling that will include the cluster membership as a variable, along with these 10 variables: the growing season, the RCM variety type, the RCM seed rate, the RCM growth duration, the RCM organic fertilizer amount per hectare, the RCM normal yield in tons per hectare at 14% MC, RCM harvesting method, crop growing for rice, source of rice seeds in the previous and upcoming seasons. And our output variables for this model will be these 3 variables: the recommended N, the recommended P, phosphorus, and the recommended K, potassium. So to summarize, with these 3 iterations of technical assessment of variables along with ERIE alignment and recommendations of which variables to keep moving forward, effectively we have reduced 70% of the data from 2,513,222 farm or fertilizer recommendations to just 776,932 recommendations, spanning initially from 2014 to 2021 on the original dataset. It now covers data from 2017 to 2021. And we have also reduced the data features from 51 variables to 20 variables. So Joanne will now focus on the clustering phase, primarily on the 7 out of 20 variables that will be used for clustering.
Thank you, Ali. So in this phase, we perform clustering on our chosen variables. Clustering can be described by 3 key ideas. So basically, it's grouping your observations based on some measure of similarity between those observations across the multiple features that describe each one of your observations. So with the creation of such groups or farm clusters, we aim to summarize and classify farms into structures that are more easily described and understood. So clustering allows for better targeting of interventions, wherein instead of one blanket recommendation, we're able to provide more specific recommendations to each of the farm clusters, which then better caters to the needs of those that belong to that cluster. But despite becoming more targeted or specific, we still only handle a manageable number of curated recommendations, and not just fertilizer recommendations as well, but other interventions like seeds, seminars, etc. So first, we'll discuss the criteria for selecting the clustering algorithm. Then we'll discuss in detail our chosen clustering methodology. And finally, we'll be discussing and interpreting our resulting clusters. So first, the selection criteria. Our choice of algorithm depended on the nature of ERIE's data. The dataset has 700,000 plus observations after cleaning, and processing and clustering all of that would be memory intensive and computationally expensive. So our first criteria is scalability. Erie data is also a mix of numerical and categorical variables, so our second criteria is that the algorithm must be compatible with mixed data types. So zooming in on the issue of mixed data types, the table shows continuous and categorical variables in the Erie dataset. So most of these categorical variables do not have innate order, which makes it problematic for computing the usual Euclidean type distances. And since measuring distance is an essential element of clustering, categorical variables do not lend well to direct clustering. So of course, there's the option to transform our categorical variables to numerical via one-hot encoding. However, this has been shown to generate clusters that are biased towards the one-hot encoded variables because of the difference in the scale of the distance when comparing two numerical points versus two binary points. So these are the algorithms that we found to be appropriate for handling mixed data types. So generally, there are three possible approaches: direct application of representative-based algorithms, computation of distance matrix before clustering, something like Gower matrix, and the dimensionality reduction before clustering. So we removed the distance matrix and the mini-batch k-method since they do not scale well, and we were able to generate clusters via the dimensionality reduction techniques, but based on multiple iterations and modeling results, the generated clusters of k-prototype was found to be far superior to FAMD and autoencoders. So now let's discuss the k-prototype algorithm in more detail. So k-prototype was proposed by Huang in a 1998 paper. Similar to other representative-based clustering methods, it has four main steps. First is the initial centroid selection, where we determine the initial k centroids, k being the number of clusters that we set. Second is initial allocation, where we assign the data points to the cluster groups of the centroids they are closest to. Third is reallocation, where we calculate the new centroid of the cluster and then reallocate all objects again. Last is iteration, where we repeat step 3 until the maximum iteration is reached or there is no movement in the centroids, whichever comes first. So before we can understand k-prototype, we first need to understand its base algorithms, the k-means and the k-modes. So both of which are also representative-based algorithms. K-means handles the numerical data types and uses mean as the cluster centroid and Euclidean metric for measuring the distance between 2 points. K-modes handles the categorical data types and uses the mode as the cluster centroid and simple matching as a dissimilarity metric. So in simple matching, we count how many of the categories the two objects do not have in common. So the more categories that don't match, the higher the distance. So k-prototype simply combines both algorithms in a single dissimilarity coefficient formula. Breaking down the formula, we have the first term that applies k-means to numerical variables, the second term that applies k-modes to the categorical variables, and lastly, we have the gamma, coefficient that prevents bias in favor of either data type. So according to Wang, this is by default half the average standard deviation of all numerical variables. So we generate sets of clusters for k equals 2 to k equals 10, and based on the cost function of k-prototypes, considerations of parsimony and interpretability, k equals 7 generates the most well-defined clusters for our use case. So for the interpretation of these 7 clusters, I'll now hand you over to Ali.
We now discuss the results of the k-prototype clustering algorithm. This algorithm resulted in 7 clusters with the following distribution. Cluster 0 takes 52% of the dataset. Cluster 4 is next with 13%. Cluster 3, 11%. Cluster 2, 8%. Cluster 6, 8%. Cluster 5 and 1, 4%. What we have done next is to do EDA, or exploratory data analysis, on these clusters, and the characteristics of these farms per cluster were plotted on a radar chart based on the percentage of the data that has those characteristics for each cluster. Each cluster has its own distinct characteristics, and we analyze it using 5 aspects of the clustered variables, which is cropping intensity, water regime, crop establishment, water supply status, and seed source. So here, as you can see, each corner represents the share of the farms that aligns with such aspect in a particular cluster. For example, this means that 100% of those in this cluster have a cropping intensity of 2 or more crops. Same goes for the other variables here. This means that 80% of the data has irrigation as its water regime, and so on and so forth. So with that, here are the cluster interpretation results, which can be super clustered in the following categories as requested by ERIE. We have the transplanted irrigated supercluster composed of cluster 0. So this supercluster comprises 52% of the data set and is most notable for it having high cropping intensity, having seed sourced by the Department of Agriculture, having adequate water supply. And what sets it apart from the other superclusters is that it is mostly irrigated and it mostly utilizes manual transplanting. For the second supercluster, comprised of clusters 1, 3, and 4, which is 28% of the data, we have seeded irrigated. It shares the same characteristics as the transplanted irrigated, with the difference that it is mostly seeded instead of being manually transplanted. The last supercluster covers 20% of the data, and this is differentiated from the first two superclusters by it being rain-fed. To make our results more intuitive for ERIE, we have developed an interactive format of the visualizations that we provided to ERIE in a turnover workshop at the end of the project so that ERIE can explore the characteristics of the clusters more for their own use case. But we use it here as well to demonstrate how the clusters make sense. In general, this is how the distribution of clusters are in the whole Philippines, with frequency of each cluster being represented by the height of the bars. So we can see here that the pink bars take majority of the amount of data, which is 52% of the whole data set. Cluster 4 and 3 is next here with 13 and 11% represented by the green and yellow bars, respectively. We also analyzed these results per cluster and supercluster. So we discussed first the transplanted irrigated supercluster of cluster 0. Again, 52% of the data can be seen here. We see that the clustering is intuitive in these areas because these areas are known for farming in the Philippines. This cluster actually sits on top of the biggest farming fields in the Philippines, which are Region 2 and Region 3. If we take a look at the reader plot on the lower right of the screen, this is aligned with expectations since farms in these areas are known to use these practices like irrigation instead of being rain-fed, and the farmers here do manual transplanting instead of using seeded crops. Next, we discuss the seeded irrigated superclusters of clusters 1, 3, and 4, which are notable for high cropping intensity, average use of seeds sourced from DA, and having adequate water supply by the majority. And what differentiates this from this first supercluster is the characteristic of the majority, to use irrigated water and have seeded crop as practice. So for instance, in cluster 1, this is the same with cluster 0. So they are farm-driven in these areas, and the only slight difference is that they haven't been practicing fully the practice of manual transplantation, and majority uses seeded crop practice still. 4% of the data is in this cluster, and it is also prominent in the large rice farms of Region 3 and western part of the Philippines, which also makes sense because Western Visayas is said to be the second top rice producer in the country. Next, 11% of the data is under Cluster 3. Cluster 3 has similar features as Cluster 1, with the difference that more of its farms are practicing seeded crop method, and it is mostly found in the lowland areas of the Philippines. Last for this supercluster is Cluster 4 with 13% of data. This is the second highest cluster, prominent on the Bicol, Visayas, and Mindanao regions. And this is good because it is clearly delineated with Cluster 0, which is predominantly in Luzon. Next, for transplanted rain-fed superclusters of Cluster 2, 5, and 6, which is differentiated from the two superclusters with its water regime being rain-fed. So for Cluster 2, we see that 8% of data is under this cluster, and it's prominent on the eastern side of the Philippines. And this makes sense because geographically, the eastern side of the Philippines is really abundant in rain, which supports the insides of this cluster. As can be seen on the radar plot on the lower right of the figure, this cluster is known for having high crops per year as opposed to here in Cluster 5. So here, 4% of the data is in this cluster, and it is prominent on the eastern part of the Philippines, again, because of it being coastal and maybe being typhoon or rainfall. It can be seen on the northern part of the of the Philippines as well. And this is understandable that there are members of the Cluster 5 in this area because this area is the rice capital of the Philippines and it has the largest plain that is suitable for farming. And as such, it is expected that some of these farms are new or small, and as such, they don't have more than two crops per year, and they rely being rain-fed, even if in reality, majority of the big farms in this area are already irrigated, as seen in Cluster 0. So as you can see on the radar plot, this is different from the previous cluster because it has less than two crops per year, and it has adequate water supply, which the previous cluster does not have. As such, we have the last cluster, which has the combined characteristics of cluster 2 and 5. So 8% of the data is here in this cluster, and it is prominent on the eastern side of the Philippines because of the geographical tendency, again, of it to be rain-fed. Farms in this cluster enjoy high cropping intensity while having adequate water supply. It is to be noted that this cluster analysis is visualized using the filtered data that was expounded on phase 1 from 2017 onwards and is plotted cumulatively on the visualization platform for cluster analysis and ERI approval of cluster categorizations. So the temporal aspect of this analysis of the cluster is not part of the scope of this project, but is still possible with the use of this visualization platform that will be provided to ERI for different use cases. So that's it for the clustering phase. Sam will now discuss the next phase, which is modeling the fertilizer recommendation, which will focus on these filtered variables we discussed in phase 1, including the new variable generated by phase 2, which is cluster membership.
So moving on to phase 3, this is where we use the clusters we just created as an input to a model that would predict fertilizer recommendations. So just to recap, our main goal is really to streamline the RCM questionnaire. And on phase 1, we chose the variables we would like to cluster and those we'd like to retain. So for phase 2, we fed the clustered variables into an algorithm to assign cluster memberships to each of the farm recommendations. And on phase 3, we take the cluster groups we created along with the retained variables as input to our models to predict NPK fertilizer levels. So this somewhat emulates the RCM recommendations. So in discussing phase 2, we'll first cover our methodology in selecting our final models, our results, and then we'll explain how we assess these results. So let's first discuss our methodology. These are the models that we initially considered, but we removed half of them due to various reasons. So first, we removed lassos since current ERI algorithms use basically all of the variables, and lasso tends to auto-select features. So we also removed KNN and random forest because of very long training times. And finally, we also removed neural networks since we may encounter issues in terms of interpretability and operationalization. So we end up with just 4 models: linear regression, bridge, CatBoost, and light GBM. So this slide shows the pre-processing steps that we did for the models. As you can see, CatBoost required basically no pre-processing, while light GBM only required encoding categorical features to integers. So this is how we decided on our final cluster. We have our squared scores on the y-axis, our models for the x-axis, and marker colors indicate the cluster results used. So for example, on the highlighted area, this is how CatBoost performed in predicting nitrogen levels. We can see that K prototypes is at the top with around 90%, FAMD obtained around 90%, and autoencoder clusters are at the bottom with roughly 87%. And this is really consistent with the rest of the tests. K prototype clusters perform the best across all models, across all target variables. So we decided to proceed with K prototypes as our final clustering algorithm. So now on to the predictive model selection. The plots here show our squared scores on the y-axis against training times on the x-axis. And what we noted is that our CatBoost models perform at the same level as our light GBM models, but they trained a lot faster. So for example, for nitrogen, the final CatBoost model took only 24 seconds to train, while light GBM required more than 1 minute. So zooming into the test scores for these two, they are nearly identical. But considering that it trained a lot faster, and because of its much simpler pre-processing pipeline, we proceeded with CatBoost as our final model. So one important trait of models is their robustness, their ability to predict target values for data it hasn't seen before. So to ensure robustness, we employed what is called a train test value split. This means that we train only on our 80% of our data and use the remaining 20% of our data as a test set. So for our train set, we used five-fold cross-validation. This is how five-fold cross-validation works. We take 80% of our data, then split it into five. Then for each iteration, we use one of these sets as our test set while keeping the other four as our train set. So this helps us ensure robustness in every step of our training. So having covered our methodology, let's discuss the modeling results. Here are the results. On the left, we have test scores during training, while on the right, we have the scores when we tested the models on our own holdout set. And as you can see, they are nearly identical. So this gives us confidence that we're not overfitting. So to assess the model performance in more tangible terms, we also calculated for the MAE and the MEP scores that you see here. On average, we are seeing deviations of 4 kilograms for nitrogen, 1.2 kilograms for potassium, and 2.4 kilograms for phosphorus compared to the actual RCM recommendation. So these translate to around 5% for nitrogen and 6%. We then use permutation importance to see the variable importances of each feature. And we saw that overall, normal yield came up as the most important feature, which is consistent with NPK calculations in the RCM document. However, we also saw that four variables are largely responsible for the predictions: normal yield, cluster membership, growing season, and harvesting method. So we thought, what if we just retain these four variables? Here are the results. As expected, we saw a dip in performance since we have less information to work with. So this drop ranges from 1.7% for nitrogen to 5% for potassium. And here are the results in absolute terms. On average, our predictions are off by another 0.6 kilograms, 0.2 kilograms, and 0.3 kilograms for nitrogen, phosphorus, and potassium respectively. And in the next few slides, Buddy will explain how we assess the acceptability of these results.
In the final part of our modeling process, we ask ourselves, is the model performance of Project Terra considered acceptable in practice? We find answering this question important, as the value of Project Terra can only be realized if it can be used in the operations of ERE. And in answering these questions, we look into these three things. The first is RRL. That is to compare Project Terra's performance against similar studies. Next is to look into the typical ranges of NPK applications. ERE mentioned that it is acceptable to recommend fertilizer amounts in ranges rather than a point estimate. Hence, we can compare the implied range of Project Terra using mean absolute error or MAE to the ranges of generic NPK recommendations. Finally, and perhaps the most important, we discuss the results to ERE, the experts in these fields, to get their feedback. Fortunately, ERE considered Project Terra's model performance to be generally acceptable for operationalization. But before we deep dive into the assessment of the model performance, let's have a quick recap of our model performances for the two scenarios that was discussed by Sam earlier. The model performance of all retained variable scenario is 82.9% to 92.6%. Under this scenario, we would only need to ask 11 questions in the farmer interviews, as opposed to 17 questions. On the other hand, incorporating only top four variables in the model would have slightly lower accuracies of 77.9% to 90.9%. But even if this has slightly lower accuracy, more business value can be realized under this scenario. Why? Because under this scenario, we would only need to ask 4 questions in the farmer interviews. Hence, more time will be saved in the interview, and that time saved can be used to interview more farmers. Hence, we need to see if either of these scenarios are acceptable. Now, we can go to the first model performance, the RRL. This is what we found out. Terra's model performance is better than most of related studies. We are benchmarking Terra's model performance against the highlighted figures. We note, however, that the work of Kumar 2021 includes other environmental variables such as soil type, soil pH, humidity, which are not present with the database, hence may not be fully comparable. The key takeaway in this slide is that Terra's model performance is relatively better than related studies. Next model performance assessment is to look into the typical ranges of NPK applications. Based on the ERI Knowledge Bank Online, which we also confirmed with them, the typical range of generic NPK recommendation is plus minus 5 kilograms per hectare for N, P, and K. We can now compare this with Terra's MAE. So here is the key takeaway. Project Terra's ranges from MAE are within the range of publicly available generic NPK fertilizer recommendations. In this graph, we plotted the range of generic NPK recommendations. And now we can see that Terra's implied range for recommended N has narrower ranges than the generic one of plus minus 5 kilograms. This implies that the results may be acceptable. Such observation is also true for recommended P and recommended K. Lastly, client discussions. Last June 3, we had a 2-hour discussion on the matter. And ERI generally expressed satisfaction on accuracy levels. However, they still have to discern and choose between the two scenarios. To discuss the final phase of Project Terra, here is Joanne.
Yes, thank you, Eddie. So to allow for better appreciation of the field of data science, we provided a training workshop for the staff at ERI on the fundamentals of data science and the use of the project's chosen algorithms. So we conducted a 2-day workshop with the curriculum as shown on the slide. So the first part was a series of lectures and presentations on the concepts and algorithms behind the project. And the second part consisted of demonstrations and hands-on exercises on the visualization platform and the new fertilizer recommendation platform developed from the project. So here are some snapshots taken during the workshop. And a message sent is only as good as a message received. And in our case, the ERI team was very receptive and took to the data science topics quite naturally. So we hope that the workshop and the project in general could inform your future policymaking and inspire more data science projects and researches at ERI. So after going through the 4 project phases, we now discuss how we operationalize the model. So to recap, one of our goals is to streamline the questionnaire in an effort to make RCM more efficient. The status quo is that extension workers ask 17 questions during the farmer interviews before they can provide recommendations. Using Project Terra, the questions are reduced to just 11 plus the 1 cluster variable if the farmer is already registered, and 16 questions for new farmers, an additional 5 questions to determine cluster membership. The version of the model that uses only the top 4 variables, namely cluster, normal yield, growing season, and harvesting method, further reduces these questions to just 3 plus 1 cluster variable if you're a registered farmer, and 8 questions if you're a new farmer. That is 3 with an additional 5 to determine cluster membership. So we created an online application for this. We used GitHub and Streamlit, which are popular websites for programmers and software developers. So GitHub is used for hosting your work, storing files, tracking revisions, and collaborating with fellow programmers. And Streamlit allows you to quickly and easily build, deploy, and distribute your Python-based codes and models. So the said platforms also allows the programs to be accessible to anyone with internet. So with the application, we can get the cluster membership of a farm, ranges for nitrogen, phosphorus, and potassium, and SHAP plots that allow us to see the contributions of each farm characteristic to the prediction generated. So now I'll hand you over to Wedi.
In this section, we discuss the business value. Here we provide the overview of the quantification of business value of the project. First, we need to determine the time saved because of Project Terra. Next, this time saved would be translated to more farmers that can be interviewed. And so we estimate the total number of farmers which can potentially benefit from Project Terra. Now, using the figures on estimated increase in income and yield due to the use of RCM, we can now calculate the business value using increase in income in peso and increase in yield in kilograms. Regarding the time saved because of Project Terra, the interview time of 10 to 15 minutes will be significantly decreased. Under all retained variable scenario, the interview time will be decreased to 8 minutes. While for the top 4 variables, this will be reduced to 3 to 6 minutes. We now discuss the quantified business value. The estimated increase in farmers' yield in 1 to 3 years of Project Terra's full implementation is 22.5 million kilograms under the all retained variable scenario, and this represents a 20% increase in farmers' yield from the status quo, and 38 million kilograms under the top four variable scenario, a 126% increase from the status quo. On the other hand, the estimated increase in farmers' income in 1 to 3 years of Project Terra's full implementation is 405 million pesos under the all retained variable scenario, a 20% increase from the status quo, and 683.5 million pesos under the top four variable scenario, which is a 126% increase from the status quo. Now, to conclude our session, we go back to the three big ideas of Project Terra. The first big idea is that Project Terra helps more farmers get access to fertilizer recommendations by streamlining the interview process. Second, Project Terra uses farm clusters to predict the fertilizer recommendations or NPK recommendations. Model performance was also well accepted by ERI, the project sponsor. Lastly, the increase in farmers' income is estimated to be at least 400 million pesos. And as Project Terra comes to close, we can't help but notice how big ideas tend to gravitate towards numbers. The minutes we would have saved in the farmers' interviews, the performance or accuracy metric of the model, the business value of the project. But these big ideas do not trump the big purpose of Project Terra, which is about the human narrative behind these figures. And that is, in any way we can, with the power and potential of data science, we do not only improve metrics, but also uplift lives, especially of our Filipino farmers. Again, this is Project Terra, clustering farm characteristics for the rice crop manager fertilizer recommendation algorithm, a project dedicated to uplifting lives. We are now ready to take your questions.
Thank you very much, sir and ma'am. Hello, thank you so much, ma'am and sir, or the Terra project team for a very comprehensive presentation and information. And the salient point in the presentation is clustering farm characteristics using a data science methodologies. At this point in time, we'll now move on to the question and answer by our participants. And I have here one question from Ronald. Sir, do you consider the inherent fertility of the soil in the parameters or variables collected in the interview schedule? Who will answer the question, sir, ma'am?
Yep, hello. Maybe confirm if you can hear us.
Yes.
Okay,
Yes.
perfect.
Yeah.
Okay. And first of all, we want to mention that we are data scientists, and this is a close partnership with the experts in this field, which is ERI. So to answer the question whether or not a fertility was included or incorporated, the answer is yes. So during our discussion with the domain experts in this area, there are there are different levels of NPK fertility, such as low, follow wet, and high. And there are a lot of parameters for the categorization of that fertility. For example, the location of the area, how many crops are being planted in the area. So to a shortcut answer to that, and also I think Miss Weng Castillo also provided insights on that in our Facebook comment page. So you may also refer to that, but the answer is yes. We definitely included fertility in our analysis.
Thank you, sir, for that answer. Another question in the Facebook user. My questions are, how important is data science as applied to agriculture? And what are the requirements for the agriculturists in the Philippines to start to learn data science? Sir, ma'am?
Okay. I can briefly answer that, and then I think some of my teammates can also provide their perspective on this. First of all, data science provides actionable insights for agriculturists. I think for us, even if we only worked on Project Terra for some months, we were really excited because we saw a lot of opportunities to apply data science. So, for example, you can predict palay prices using data science. You can also detect plant diseases using data science, and also perhaps cluster farms. For example, what we did in Project Terra is that we clustered farms for better intervention or targeted programs for Department of Agriculture. So definitely, to answer the question how important data science is in agriculture, I would say it's very important because it would harness insights that will be very interesting and may not be obvious in the naked eye. And to answer the question whether what are the requirements to become a data scientist and also an agriculturist, we also mentioned in the Facebook comment that the only hard requirement is really willingness to learn. To share with you, data science is has three aspects. It's programming, math, and domain knowledge. In terms of domain knowledge, because you're already agriculturist, you already have that. So that alone is very important in terms of harnessing insights using data science. The only mountains that we need to surmount is really programming and math. Luckily, we live in this age where information is everywhere. So there's a lot of free courses or learning materials online. But definitely, if you want to take further studies, AIM offers Masters of Science in Data Science. And actually, my teammates here were all graduates of Masters of Science in Data Science. I'll take a pause there, and perhaps my teammates can also provide perspective on how important data science is in agriculture.
I think you have answered. Hello, can you hear me?
Yep. We can
Ayun.
perfectly hear you.
Yes, I think Wendy has said a lot. But just to add, as we go through a more digitally advanced age, we get more and more information. We gather, even in our own research, diba, we gather a lot of data. And data science is a tool to make us more efficient, in short. Like computers, diba? If we just type manually in our typewriters, we will be slow. But if we have the tools and technology of data science, our researches could be done faster because we have a lot of data that is available to us, and using data science we can gather insights faster, uh, faster than ever before, because the data right now in this age is 100 times more than the data hundreds of years ago, because of the advancements in technology. So yun lang po yung ma-add ko sa question na yun. Thank you po for the question.
Okay, thank you so much, ma'am. There's a follow-up question of Ronald. Now, how do you do that? Now, he is mentioning about the soil fertility, sir. Do you actually establish crop and have it analyzed aside from the farmer's interview? Those question is related to soil inherent fertility, sir.
I believe in this aspect, we also need to get the perspective of Erie. But based on what we're seeing is that, based on the information provided to us as data scientists, what we saw is that beyond the farmer interviews, there is this location variable where Erie um, also have the information regarding the inherent fertility in the area. So that's from a data science perspective. Maybe just to comfort the perspective here, as long as the fertility level was incorporated in the analysis, I think in some way or another, where may it be in the location or the farmer interview, what's important is that the information that the fertility is already embedded in the model. In what way were these determined is something that we also want to align with Erie. But definitely, what we're comforted as of this point is that that very important variables is already applied in the model.
Okay, thank you. I hope Ronald got the right answer. Ronald, are you satisfied with the answer? Okay, so another question, sir, from Grace. Um, may you consider translating this information consumable to all rice farmers?
Perhaps some of my teammates can also answer that, and how we can laymanize our results. And maybe to add perspective on that, definitely we can do that. What we've shown to you today is more on the technical and business value aspect. When we talk to farmers, what we are after is really on impact. For example, we showed earlier that given Project Terra, the expected increase in farmers' income with its full implementation is around additional of 400 million pesos. And they're also expected to, let's say, for example, the successful implementation of this program, there's also around 22 million kilograms, tons increase in terms of yield. So when we talk to them, definitely we're going to laymanize the terms and we're going to highlight what's in it for them. Because sometimes the very first thing that we need to do is to get their buy-in. Because without their buy-in, they're not going to embrace Project Terra and that they're not going to apply the recommendations, the fertilizer recommendations that were put forward in the platform. So to answer the question whether or not we're going to do it, if given the chance that we're going to talk to the farmers themselves, definitely we're going to do that. At this point, what we're after is to share the knowledge to ERI and also the Department of Agriculture.
Okay, thank you, sir. Now, another question from the Facebook user. Now, did you conduct soil sampling and analysis to determine the nutrient present in the soil?
Okay. We would like to highlight that this project Terra is a close collaboration with ERI. As mentioned earlier, data science is really more of a multidisciplinary field for programming, math, and domain knowledge. In terms of programming and math, our team covered it extensively. In terms of the domain expert in this field, this is something that we really collaborated closely with ERI. So to answer the question to did you conduct soil sampling and analysis, perhaps ERI could provide perspective on this. I would just like to reiterate earlier that the fertility levels what incorporated in our model. So yep, if there's a perspective that ERI could share, we would definitely appreciate that. But perhaps we can just comment it. We can coordinate with Ms. Weng later, the head of the RCM Philippines, to answer that question. So we will yep, we'll perhaps comment on that.
Okay, thank
Offline.
you, sir. Another one. Now, this project is very important, and this is one way to for us to be competitive with other ASEAN countries. Now, have you presented this new idea to the new administration of the Department of Agriculture?
At this point, what we did is that we presented this to ERI, the experts in this field, and ERI and Department of Agriculture. I believe they have their close collaboration as well. So through ERI, we hope that the Department of Agriculture would also look into the results of this study. Maybe to just to add the perspective, no, on the timing of these. This project was just concluded around a month ago. So this is really a fresh study. And at this point, we're really in the stage of knowledge transfer to different players. So whether the first thing that we did is really to share it to ERI, but definitely through in the next few weeks or months, we can talk to the Department of Agriculture and other departments that perhaps the new administration would want us to talk to. So yep, we're really in this very exciting stage of knowledge transfer.
Okay, thank you, sir. Another question from Ma'am Gigi. Do you think plus or minus 5 kilos per hectare of NPK is all that can be supplemented in a rice farm? Because in a practice, it is a way higher. That is also what I am supposed to ask because agriculturist has specific skills set and knowledge set.
Mhm. Yes, I think that's a very important question. What we showed earlier regarding the plus minus 5 kilograms per hectare is really for us to benchmark whether or not the forecast of our model is good. So the to provide perspective on the plus minus 5 kilograms per hectare, that's what we see based on the knowledge bank that we see online with ERI and also as with regards to the discussion with them. That's the usual range of fertilizer recommendation, plus minus 5 kilograms per hectare. If our model, let's say for example, can provide a range of fertilizer recommendation that is narrower than plus minus 5 kilograms per hectare, it means that our model is more accurate than the general practice. And that in its way is good because that's really the power of data science to help us become more accurate about things. So for example, if the general practice is plus minus 5 kilograms per hectare or plus minus 10 kilograms per hectare, but then through the use of data science, it would tell you that the optimal range is around plus minus 2 kilograms per hectare. It means that we are more confident with the prediction of the model. Hence, we would be able to optimize the application of our fertilizers. So given that the results of our study show that our prediction is narrower than plus minus 5 kilograms, it means that it's more accurate or it can provide more reliable and accurate estimates than the wider range of plus minus 5 kilograms per hectare. We hope we adequately answered the question, but if not, we can definitely chat offline or through the Facebook call.
Okay,
May I just, sorry po.
Yes,
May I
yes,
just
this
add
one.
lang din po. So the model produces fertilizer recommendations, right? So what we can see is maybe if we put in the inputs in the program, we get a fertilizer recommendation of 100 um, kilograms per hectare for nitrogen. So what the plus minus 5 is that instead of providing a point forecast of 100, we provide 95 to 105. So that's the plus minus 5 kilograms. So and that's as Wedi said, to it it's a measure of how accurate or how well we do compared to what we see in the knowledge bank or in the other recommendations. So, thank you.
Oh, okay. So thank you so much, sir. So we have still three questions in the list, but I don't know with the administrator if you have still enough time to discuss on this one, or they will the our speaker will just answer it in private. Is that okay?
Dr. Nutarte, perhaps we can give Ms. Wen Castillo of EV a few minutes to
Questions
address some of the questions.
soil fertility level.
Okay, Dr. Wing, please.
Magfe-feedback. Ay, hindi ko pa kayo narinig. Anyway, I'll just comment on that. Ano po, even yung sa soil sampling. So for the inherent soil fertility, we consider that what we did to calculate or to formulate our algorithms in RCM, we use the results of the nutrient emission plot technique trials. In that trial, we determine the indigenous nutrient supply um, in the soil for nitrogen, phosphorus, and potassium. So we conducted a lot of nutrient emission plot trials nationwide. So in that methodology, again, we determine the indigenous nutrient supply. So yung pong mga indigenous nutrient supply or INS are the yields obtained without the addition of fertilizers. For example, we determine the yield in minus nitrogen, yield in minus phosphorus, and yield in minus potassium. Of course, soil is one of the important sources of nutrients, but aside from the soil, we also consider nutrients from irrigation water, from organic materials that's being added to the soil, like the rice straw. Rice straw is a very good source of potassium. 85% of potassium absorbed by the mature plant is in the straw. So we consider those, not only the soil. With regards to the soil testing or soil sampling, we did that in our previous activities prior actually to the um, formulation of the algorithms for RCM. We did that in several locations also. So, ayun po.
Okay, thank you so much, Doc Weng, for that answer. So I think Ronald and the rest of the participants had a clear vision of the project. Let's move on. Thank you so much, Terra Project and the team. Now, at this point in time, I would like to read the certificate of recognition for the Terra Project. Certificate of appreciation is presented to Project Terra team for sharing their expertise and knowledge in their paper entitled Clustering Farm Characteristics for Integration in Rice Crop Managers Fertilizer Recommendation Algorithm using Data Science Methodologies. Given this 23rd day of July 2022 during the second International PAA Virtual Congress and 2022 Philippine Agriculturist Summit. Signed, Roberto F. Ranula Jr., Board of Trustees Chairman. Signed, Dr. Louis A. Divina Gracia, PAA National President. Thank you so much, project team, for sharing your expertise. A big hand for our first speakers. Clap naman kayo dyan sa Facebook. Thank you, sir, ma'am.
Maraming
Thank you so
salamat. Thank you very much,
much. Thank you,
everyone. Have a great
everyone.
day.
Thank you.
Good night, everyone. Now, for
Thank
our
you.
second topic, entitled Digital Circular Agriculture and Resilient Rice-Based Agri-Food Hub. Now, this topic will be discussed by a dynamic Doctor of Philosophy graduate at Cornell University, Ithaca, New York, USA. At the same time, his MPS at the same university. Our speaker receives various awards as public servant, to name a few: Presidential Lingkod Bayan, National Land Use Management and Protection, Achievement Award for Soil and Management Research and Development, and presently, our speaker is the co-chair, Technical Advisory Group of the Office of the Secretary, Department of Agriculture. Likewise, independent consultant of the Department of Agriculture, particularly at the Bureau of Soil and Water Management, and at the same time, Board of Director of Planters Product. Now, ladies and gentlemen, the man I am referring to is Dr. Rogelio N. Concepcion. Sir, good morning.
Good morning po. I am so excited after listening the lectures of the on digital study. This is very important. Shall I?
Yes, sir.
Okay. I'd like to introduce first what is the interest of my paper. The interest of my paper is to discuss the geoclimate system, crop technology approach to agriculture and rice-based cultivation. It will also attempt to identify the minimum database for sustainable land management. This, I think, that minimum database is a complementation to the study of the data science project. I think that's a very important complementation. I heard the mega data requirement, but in agriculture, to make it simple, I think it is very important to define what is in fact the minimum database to make an efficient use of fertilizer, especially fertilizer and farming system. Okay, thank you. Now, next slide, please. Okay, this is a simple chart to understand why we should be aside from being analytical, there should be an attempt to talk about what are the practical information that could be understood by the farmer. Because as you would see, the science based for sustainable land management is, when given out to the public for use, is that we call it a technology package. But technology package development is not complete by itself, because it will go as is being catered to the farming community. There are transformation. Yes, there are transformation going on the initial transformation. That's adoption on letter O. The farmer-to-farmer sharing of and transfer of adaptive SLM will practically redefine the technology, and that will be a contribution to what we call the best practices that we can see in the field. On the other side, another pathway is adoption, letter A. This is on-farm user reformulation of SM. This actually trying to be more specific, the technology being more specific to the area and capacity of the farmer. Okay, so this is very important. Yes, next slide, please. Next slide, please. No, go ahead. Next slide. Next slide. Now, Agriculture, from the point of its globality, it recognizes that agriculture has multiple functions in addition to producing food. It covers a range of socioeconomic, ecological values such as environmental protection, landscape preservation, and rural employment. That's in fact a big challenge. It's not simply putting the technology and knowledge there. Agriculture has to satisfy the different multifunctionality of agriculture. Next slide, please. Now, what are the emerging issues, challenges for globalization? We knew that economic globalization put together people of different races, food preferences, and share a common dining table that has become to be a key game changer in the production, distribution, storage, and consumption. That's the value chain. And as more food are produced, soil health, water availability are severely degraded, and this should be recognized very properly in any recommendation. This and scarce. It will be and then the climate change and increasing cost of oil-based fertilizers are added barriers to sustainable development and to the resilience of the agriculture, food, and feed crops. Next slide, please. Next slide, please. Next slide, please. Okay, the guiding framework. The future of agriculture is digital, and I agree with the first speaker that, in fact, agriculture is very crucial now. We live in I would like to quote Kerner. He said, we live in digital society. Digital social society is not just technology, but a comprehensive social organization where the information and its exchange play a major role. Next slide, please. Now, the governing principle. The governing principle is this very crucial now. This should be put on the ground very carefully. Technology is not only solution. Data are not an information, but digital technology has enormous potential to improve food security. Now, let's now go into the next topic. This is now the core of all argument on climate change, the climate zones, risks, and opportunities. Now, let's go to the next slide, please. Now, in the Philippines, we have two major climates, as dictated by our monsoon, our northeast monsoon, which is practically the dry season, and then the southwest monsoon, which is the wet season. This particular climate situation defines how agriculture, how technology will be more effective when it's not put on the ground. Okay, next slide, please. I assemble an analysis of the climate a little bit more comprehensive. You will note that we have 4 climate types: type 1, type 2, type 3, type 4. But we should also understand that the 4 climates are subdivided into main and transitional climate. The main climate is type 1, which is basically the dry, we call it a seasonally arid region that is in the north of Ilocos region. And then type 4 are the dry season, that's basically Mindanao. The transitional climate, climate 2 is the transitional climate of climate 4. Climate 2 is on the border of climate 4. So climate 2 is no dry season, and then it's almost similar to type 4, but a shorter one. And then climate 3 is again a transition of climate 3. Putting together the transition and the main climate, that will result to what we call agroecological zones of the country. Now, before I go to the next slide, I would like to indicate that our climate are basically influenced by one particular important phenomenon on the rain shadow effect of the mountain area. If you look at the map on the left side and the arrow, you'll see that the type 4 or the close to the shoreline, that's the Sierra Madre, and then followed by yellow, that is the Cagayan Valley, but you have the corn, and then the last being the driest is in the Ilocos region. That is always the situation because in the rain shadow effect, it is an area of significantly reduced rainfall behind one mountain ranges on the side facing away from the prevailing, that's what we call the leeward side. Okay, next slide, please. Now, these are the Amihan and the Habagat. as it is now, these are what you call the present planting schedule, planting calendar. Now you see that the county is almost synonymous, every spot in the county is synonymous to every very specific crop calendar. Okay, next slide, please. Now this is I'm a little bit more interested. I thought it would be useful to really define the zones of agriculture in terms of the capacity of area, the capacity of climate to support the sustainable growth of the plant. So the direct climate zone are composed of climate type 1 and 3, and the wet agroclimate zone is composed of climate 2 and 4. I did not attempt to do another regrouping because this is information that's already known to everybody, and we don't have to reconstruct. And as I told you, the planting calendar that is now well established across the county is dictated by the different climate zone. Okay. Okay, next slide, please. Now, next slide. Okay. No, okay. Look, if you look at our program on the is that the PRDP, where we have, you see that all the crops that are promoted in the county are subjected to various strict typhoon. They're all affected by typhoon. It's quite amazing how those crops survive. But I know after a certain time, crops that are permanent growth in the area has developed some kind of a natural adaptation capacity to climate changes across time. Please, on next slide. Next slide, please. Okay. Okay, next slide. That's already. But one slide that I did not, I missed to connect. I have developed what you call the climate risk zones. I'm going to say maybe send this later after my lecture. The climate risk zones identify 5 zones in the country. Climate risk zone number 1 is in northern Luzon, 2 is in the central southern Tagalog, 3 is in the Visayas, 4 in Mindanao. I'll share this map, this table because I failed to connect that. Okay. No. Back to the. Please back to the. Yeah. Okay. This is a very interesting characteristics of the climate, which will determine the efficiency of any fertilizer applied in the field. Now, the rainfall is very clear. We have dry and wet, but the temperature, take note of the temperature, it is practically hot almost throughout the year, except for the month of November to February. Even now, this month of November and February are experiencing very high temperature in the day. Okay. Okay, let's go. Next slide. Ito yung epekto ng ecological impacts of climate change. On high temperature, the surface organic matter are lost due to soil surface sealing and soil erosion and poor groundwater. It also affects time and duration of each stage of plant phenology. It accelerates senescence, that is aging, and it also causes flower abortion. Now, I think this is an area where all the researchers should look into. If you just look at the data of production and so on, but if you don't get all of this, like the impact of temperature, especially on senescence and plant phenology, then our data will be our recommendation could be in trouble. And this also create a large variation. The coefficient of variation for productivity will be very large because of this impact. Okay, next slide, please. Now let us look at the historical trend of soil fertility due to soil fertility mismanagement. Okay, 1970, nitrogen fertilizer are generally required alone only. In 1970 to 1980, the nitrogen plus phosphorus are generally required. In 1980 to 1990, nitrogen, phosphorus, and potassium, including micronutrients, are generally required. What is the message? The message is there are too much soil degradation that happen on account of our inability to use especially urea that influence this tinatawag na nutrient losses. No? Okay. Now, Ito yung istorya that's linked to the first slide before this. You will see that the exceedance of the nitrogen and phosphorus has a very important ratio. The normal ratio is 4 unit of nitrogen for every 4 unit of nitrogen for every unit of phosphorus. If you change that equation, you'll see that on the next slide. Next slide, please. You'll see that this is the area where should be the final basis of fertilizer application. The practice is we put so much emphasis on basal application of fertilizer followed by some minor, but it very clearly says that the flowering penology states, the flowering penology of the crop is the most crucial part of fertilizer management. In those areas, you'll see that potash is very much required, nitrogen, sulfur, and phosphate. It was also shown by the farmer in the Visayas that they found it very important that if you apply potash 1 month before flowering, then you get better yield and mabigat ang palay, heavier, more impact. Okay? Now, ito yung I think especially in rice, this is very important because rice, we incorporate rice straw. And this is now, the incorporation of rice straw should be an important part of our technology innovation. We should be more efficient in incorporating rice straw after harvest. And you will know that nitrogen in the grain is 137 kilos, and potash in the grain is in the straw is 168. Now, important is the nitrogen in the grain. So much nitrogen, some nitrogen are removed from the area on account of grain harvest. Ang tawag doon ay nutrient export losses. Nutrient export. That when you remove the grain from the crop, that the nutrient contained in the grain are practically part of losses of nutrients. Kaya yung ating analysis of losses should not be on the soil only, but also on the crop. The amount of nutrients that are associated with crop that being removed. If you see vegetables, how much of those nutrients are in the leaves, and analyze it, and then use that as a base for fertilization. Okay? Now, what is balanced fertilization? This is balanced fertilization was introduced during the time of Secretary Escudero. I was the director. And there was an issue of very high cost of increasing cost of urea, which is happening now. Then we introduced yung tinatawag ng balanced fertilization, which is a program that all of the nutrients supplied to the soil, plant available, pool in the amount required to satisfy the plant's nutrient. Yan, ito ang definition ng balanced fertilization. No? Okay, next slide. Now this picture is very important to rice and crop penology. I think all researchers must look into the very specific relationship of your nutrient in terms of different crop growing stages. And the most crucial stage in the crop penology, yung tinatawag ng flowering penology. Flowering penology. If you notice in the last slide that when I show the amount of potash, nitrogen losses, it's actually in the area where the flowering penology is developing. Okay? Now, ito na yon. Yung principal fertilizer. There is one element that we forget in the science of fertilization. Yung fertilizer natin, urea, is feeding the plant. Okay? If you feed the plant and you increase the yield coming from the plant, then there'll be a problem of organic matter loss. That's why in the balanced fertilization, there are two elements. You use the organic fertilizer to feed the soil, that is to feed the soil, and the chemical fertilizer to feed the plant. The two basic sciences that has never been put together when we develop our nutritional requirement for the especially the SB system. And I think the initial paper that was done this is very relevant because they talk about nutrition, but feeding the plant is one aspect, but the feeding the soil is another aspect. Therefore, it tinatawag na balance participation. We try to restore the organic matter of the soil, and we try to provide enough nutrient for the growing of our crops. A very important, simple chart of balanced fertilization. Next slide, please. Now, when we established the balanced fertilization during my time, nagkaroon kami na almost 2 years trial on balanced fertilization. It shows that at any given time, yung one practicing balanced fertilization can get as always higher than 5 tons per hectare to almost 6 tons. That's quite a lot already. So, in the balanced fertilization, assured natin ang ating 5.5 kilogram, 5.5 metric tons per hectare. Assured yun, sigurado yun. Okay, at any given treatment. Now let's go to the digital rice-based color, which is and has some kind of an affinity to former paper. Now, there is a new technology that was introduced by the global scientists. They said circular agriculture. But circular agriculture is nothing but it focuses the use of minimal amount of external inputs, closing nutrient loops, regenerating soils, minimizing the impacts on the environment. In other words, circular agriculture is nothing but putting equal emphasis on manure, on compost. Okay? Next slide, please. Next slide. Next slide, please. Okay. The digital agriculture in the integrated production value chain monitoring. This combination of soil science, agronomy, and economics, which is not really my point. So digital agriculture is the use of digital technology to integrate agriculture production monitoring from field to table through the application of tools of information to make more informed decisions and improve productivity. It serves as a platform for integrated supply value chain that can be defined as an association of customers and suppliers who work together to optimize their collective performance in the creation, distribution, and various transformative value-adding support of the end product. Okay, next slide, please. The Food Systems Innovation Hub. I think it's now very important that if we can develop strategic hubs for the country, different hubs. I will have in the letter. This is very important because the food system hub is some kind of developing an area where we can provide model, we can provide some kind of a mentoring type of model that the partner can that we can work with the partner. The food system innovation hubs can provide transformative solutions to food system by bringing the right innovation faster to market in a cost-effective manner through the three key action. Hub can facilitate investments in local companies that have potential to scale, as well as in technology transformation and safety, and to prove market viability and identify latent demand for nutritious food. Okay, next slide. This is what I call the minimum variable that should be considered in fertilization in rice culture. What it shows, this is a data that the crop that are successfully harvested in each climate type, successfully harvested crop. Itong successfully harvested crop can be our indicator of crops that has adapted to the climate variability. So each one of them, if you see that the color below its chart, below its climate type, are the analysis of water balance study. You'll find that the colored area are very is exactly on the time when the rainfall is already coming down. In other words, it is created a practical method to avoid damages from typhoon. Okay? If you go to the climate type number 2, keep this slide, please. You see the same pattern. You see the harvesting on the when the rainfall is at its lowest, and repeatedly to different climate. In other words, our farmer in the countryside has almost created that their personal individual adaptive capacity to ensure that crop will be properly protected from climate variation. Okay, next slide, please. Next slide. Okay, ito yung after studying all of those, what is crucial is, ano nga yung gagawin natin? Ang crop programming that we can do to make sure na yung ating income ng farmer is income and labor is properly, the spread of our income, labor of our farmer is properly used. If you see this, meron tayo, if you are in some valleys of a mango growing area, ano mga crops that can be developed to support, that can be seasonal crops that can develop in the different climate types that's below. If you look at the harvest of the mango on the yellow, and then the different seasonal crops below, if you have those kind of crops that support the mango plantation, you consider the farmer are insured for their income, monthly income, and insured yung kanilang food requirement, food support requirement on a practically whole year round. This is what you call crop programming. I think every study must end up with a crop programming strategy. Okay, next slide, please. Next slide. Ito yung digital agriculture, ito yung function. Ito yung ito mayroon tayong mga platforms, low elevation platform that we can take picture, makikita natin ang different process na nangyari, mineralization, and so on and so forth. This is already a part of the science that minimize yung ating natag na field work open area. Okay, next slide. Next slide, please. Okay, next slide. Next slide. Next slide. Next slide, please. Okay, okay. This is a build integrated program, and the island, island food systems connectivity, and this is information that the island system framework for food security and self-sufficiency is very relevant. Okay, thank you. Slide. Next slide, please. The impacts of the build infrastructure, it established virtual integrated food hub corridors for the consolidation and connectivity of inter-island food system hub for national food sufficiency and security. Now, when we talk about, I saw in the paper about networking. I think networking should consider a lot of factors. And the food hub corridor is a very important tool to create volume and supplies that will satisfy the market. Next slide, please. We need to establish the framework for geopathways for food systems and sustainable value chain for upscaling and consolidation of island food system, such as, but not limited to the following. Ito yung example of food system that I thought. If we were in Luzon, we could imagine if the product of Mindoro is some kind of the product of Mindoro can be an important input to the requirement of the metropolitan city. So from Mindoro, it moved to Batangas. Okay, Batangas can be the hub of the system, and then from Batangas it will move to Metro Manila growth centers and influence areas. Now, I saw in the latest report that the Mindoro and Batangas will be connected finally by bridge. This will create wonder to agriculture because Mindoro is a very big supplier of food for Metro Manila, along with Quezon, of course. For the Visayas, this is the cluster that I thought: Negros Island to Panay Island, and then feeding, consolidating the product and the hub to for Metro Cebu. Okay, in Mindanao, a very good example is the Sarangani to Davao City to Bukidnon and then to Cagayan de Oro. all of them end up into the major growth center. Major growth center. Okay, next slide, please. Next slide, please. Next slide na lang. Okay. Ito yung may recommendation. The agro-industry mechanization, improving seed varieties, and good farming practices are the first level improvement. I think there is need to for the adoption of new technology, that's digital agriculture, mechanized balanced fertilization, and green manure. You know, in the rice industry, in the wetland land, it is very important to incorporate green manure. Before we have what we call the asola, we have one very important green manure for the rice land is the mungo, and this is Spania. Mungo has a food value. So incorporating green manure to mechanize balanced fertilization is a very important technology. Okay, I think that's about all. Thank you very much. Thank you. Thank you. Thank you.
Okay. Thank you so much, Dr. Concepcion, for the nice presentation and sharing your expertise on Resilient Agri-Food Hub. So, Dr. Concepcion is now ready to entertain some questions. Anyone from the participants? Sir, I have a question. Hello, sir. Sir? Hello? Dr. Concepcion, can you hear me? Hello? Doc Concepcion. Administrator, please.
Dr. Concepcion, can you hear us?
Yes, please. Yes.
Okay, sir.
Okay.
Sir, there's a question, sir. Now, digital agriculture nowadays is the trend, particularly with the pandemic we are experiencing right now. Sir, being in the Department of Agriculture, being the co-chair in the Technical Advisory Group, what are now the plans and programs or strategies of the Department of Agriculture that this system be implemented in the local government units, especially with the devolution of the extensionists who did the extension services? Ang nakikita ko kasi, ang national has a broken line relationship with LGUs, which makes the program's implementation, monitoring, and evaluation difficult.
Doc Roger, kindly unmute po. Oh, no.
Sir, naka-mute ka, sir.
O yan.
Go ahead,
na,
sir.
Okay na yan?
Yes, sir.
Okay. What's the question again?
Digital agriculture nowadays is the trend, particularly with the pandemic that we are experiencing right now. Being in the agriculture, what are the plans and programs or strategies that this system be implemented in the local government units, especially with the devolution of extension workers who did the extension services? Ang nakikita ko kasi, the national has a broken line relationship with LGUs, which makes the program implementation, monitoring, and evaluation difficult.
Well, it's really a very difficult situation that we have now, especially agriculture is facing so much changes in technology, so much changes in the dwelling pattern of the alternative value chain for agriculture, especially. may problema tayo because, but I think what we can do is develop some kind of indie hub that we have identified, that we will identify. Magkaroon tayo doon ng mga demonstration models. The only way is to show to the partner what our technology can do, especially the digital agriculture technology is actually for monitoring and for advanced identification of potential problem that will be affecting our crop. But all of these are not totally all the provinces, and not all provinces are totally equipped with the technology. So siguro pinakamaganda diyan, the only way is balik tayo sa ating mga demonstration. Magkaroon tayo mga tinatawag na model farm that will now maybe 50 hectare. During Secretary Escudero's during that time, nagkaroon kami na 20 to 50 hectare model. Pati in that area, 50 to 20 hectare model, pati clustering of farms, yung mechanization and yung synchronous planting will also be there. Maraming mangyayari. But an important is, how do we define our model? How do we establish our model? That's the only way to link us, because yung ating extension is already gone. Wala tayong extension. We don't have the extension function at DA. Lahat na yan is already with the LGU. So the thing that we can do is to showcase, magkakaroon pa some kind of mentoring of local techniques and mentoring of farmer leaders that are in the area. And that mean magkaroon tayo ng mga demonstration farm. Instead of yung mga lecture, pakita na natin kung talaga epekto ng mga yan. Especially in fertilizer. Ang fertilizer ay kaya nagiging problema because urea has so much impact on the degradation of our organic matter. Hindi na rin-recognize yun. Kasi sinabi ko kanina, in fertilization, we feed the soil and we feed the plant at the same time. And that is where yung ating rice-based farming, yung meron tayong pag-incorporate natin rice straw properly. It's very important. Kailan may balik natin, especially for rice, kasi isang rice, para efficient ang urea, it is also cost effective.
Okay, thank you, sir, for that answer. Another question. According to the table presented, rice straw removes a lot of potassium. Can this be recycled through green manuring?
Okay. Yung recycling, actually in our recommendation on this recycling, yung farm mechanization will also result to recycling. Okay? Effective recycling yun. If we are not able to incorporate rice straw effectively, malaking nutrient loss ang nangyayari. But green manuring is different. Green manuring is the use of living plants like azola, mungo, can be green manure. Kinukultivate ang mungo, kinukultivate yan down under yung pagka nasa flowering stage yan. Tataan over yan. Cultivate over. So green manuring is the use of leguminous plants that capture nitrogen from the atmosphere, also fix that nitrogen in the soil. It also acts to restore, ipinabalik niya organic matter content in the soil profile.
Okay, sir. Thank you so much, sir. Okay, so there's a comment here. This is not a question, but just a comment.
Yes.
Maganda po yung topic kasi it talks about self-fertility in a holistic way. Balanced fertilization program. Marami naman talagang ways and means to do that. Thank you, sir. That's a comment. A comment to your very nice presentation.
Ay, maraming pong salamat.
There's another question.
Mhm.
Now, in the advent of pandemic, what are the key steps the Department of Agriculture is planning with the high cost of fertilizer? This
Okay.
coming from the local government units.
nasa stage na kasi tayo, ating stage, ating lupa, for especially rice, no? Ang ating lupa sa rice area are practically degraded already. It is on record na if you are in Central Luzon, yung fertilizer requirement can go as much as 10 to 15 bags per hectare. But if you have an new irrigated area somewhere in Kabakan or somewhere in Tagum, mas bababa ang fertilizer requirement because hindi pa na-degrade masyado. But very efficient ang rice production in Central Luzon. Pero inefficient yung reuse and management of the rice straw. Kaya ibinabalik natin yung rice straw cultivation. That's the only way. At saka yung inclusion of green manure like yung ASOLA. The ASOLA program should be put back into the system. That's very successful. In Vietnam, they're using ASOLA as a part of their green manure, natural fertilizer yun. It also absorb nagpipix ng nitrogen for use of the plant. More effective is lalo na yung ating munggo, yung ating mga legumes. And then maybe other area in terms of leaf manuring, natatawag leaf manuring, another terminology. Ang leaf manuring is the use of mga dahon. Alam best bet yan, ating moringa. Moringa is a very important source of nitrogen for the plant. Pag yan na-process natin and apply that in the field, that lead to soil restoration. It also improve the efficiency of applied urea fertilizer. Kasi ang laki ng losses natin sa urea sa ngayon. It's almost 30 to 40%. Ay mainit pa ngayon. It's a very high temperature ngayon. Mas mabigat. Mas malaki ang losses. The important part of the technical fertilization is how to increase the efficiency of fertilizer applied. And the only way to do that is improve the soil organic matter in the soil profile. Very important siya. Kaya yung incorporation of legumes into the system, yung green manure, will provide a check or restoration of the soil to efficiently utilize applied fertilizer. Makakambal silang dalawa. You feed the plant, you also feed the soil. You feed the plant, di sila pinalakas ang kanyang uptake. And then yung grain yan will be transported out. Ang grain is already permanent loss. Ang ating fertilizer should be based on hindi lang sa soil. Tignan din natin amount of nutrient from the grain, rice grain. Kasi yan inaalis yan eh. It is being nutrient exportation, nutrient loss. So yung pag inalis mo yung grain, ay di wala hindi na ang laki ng nutrient so yung ating analysis should be complemented by analysis of the grain, the amount of nutrient taken out by the grain. Yun ang cost of degradation. Hindi na di-discuss yan. One of the cause of the higher the yield of a crop, the higher the degradation of the soil. Yun. I'm not saying it should be what I'm saying, the higher, because kasi ang laki ng consumption ng halaman, but yung lupa, nalalampasan na niya ang capacity ng lupa to support it. Kaya meron tayong fertilizer to add on. But meanwhile, pag hindi natin bantayan na i-monitor natin ang degradation of my organic matter in the soil, then our fertilization will be very inefficient. And that's what we're going on. Yung ating graph na pinakita kaninang graph is already showing yung inefficiency of our urea application. I think a very important fertilizer for rice is potash. Potash is adding weight. You've got more kilos per bag. Yung 50 kilo bag can add as mga 55 kilos yan in one bag. Potash is a very important fertilizer. One bag of potash, flowering penology is a very crucial step. Hindi natin ginagawa yan. But it is also done in one area. Nakita namin sa Leyte, one of the farmers doing that very successfully. Lumalaki ang kanyang yield. So we have to get away with the traditional knowledge that we have in fertilization. We should be more innovative. And it should be adaptive to soil condition and climate. Yung mataas na temperature is also creating, pag mataas ang temperature, yung halaman natin, bumibilis ang pagtanda, yung tatawag na senescence. And then if water is not available, it's even faster. Yan. So, may mga nexus ang climate, plant, and the nexus should be analyzed very properly. I did not do that because it's like long paper. but we should look at the nexus of the climate, crop, and the soil. So yung ating temperature is a game changer in rice production. Ang laki ng ginagawa niya, madaling tumanda ang halaman, natutuyo mainit. And then yung timing na kanyang flowering is advanced. Kung kulang ang tubig, nagka-advance. Kung sobrang man ang tubig, nadidelay. Nadidelay naman siya. Kasi green, produce ang grain, produce ng daon. Nasasakripisyo yung grain formation. A lot of those little things, little things of fertilization to be introduced a little bit better. Hindi lang, fertilization is one. But the art of fertilization and the art of growing the plant, na tinatawag namin plant penology, must be introduced into the system of fertilization. Kaya tinawag ko yung flowering penology for rice plant is very crucial doon sa fertilization stage.
Okay, thank you very much, sir, for that explanation. There's a comment here that potassium can be substituted by wood as.
That's right. Wood
Since the word potassium is from the phrase potash. Sir, there's a comment also if they can ask an electronic copy of your presentation.
Yes, sure. More than happy to share.
Okay. I think there's no more questions. So thank you so much, sir, for sharing your expertise and time. Now I would like to read the certificate of appreciation is presented to Dr. Rogelio N. Concepcion for sharing his expertise and knowledge in his paper entitled Digital Circular Agriculture and Resilient Rice-Based Agri-Food Hub. Given this 23rd day of July 2022 during the second International PAA Virtual Congress and 2022 Philippine Agriculturist Summit. Signed, Roberto F. Ranula Jr., Board of Trustees Chairman. Signed, Loie A. Divina Gracia, PAA National President. Thank you so much, sir. Salamat. Okay, at this time for Dr. Concepcion, please.
Okay na?
Salamat, sir.
Salamat po.
Okay.
Okay.
So,
thank you. And wish you all the best of luck.
Yes, thank you so much, sir. God bless also. Ingat.
Salamat po.
Okay, moving on to our third topic for this morning's session will be delivered by an academician, director, and CEO of prestigious Southeast Asian Office, a graduate of Doctor of Philosophy in Genetics at the University of the Philippines. To name a few of his major achievements, the Filipino Faces of Biotechnology, UN Food System Summit Champion of 2021, Distinguished Alumni Award for Rice Chemistry and Food Science Research, and many more. As to his work experience, our speaker was a crop breeding manager of corn at East-West Seed Company and presently a professor of UPLB in Crop Breeding and Genetic Resources Division, Institute of Crop Science, College of Agriculture and Food Science at the University of the Philippines. And at the same time, the current Center Director of Southeast Asian Regional Center for Graduate Study and Research in Agriculture, or SHERCA. The man I am describing is no other than Dr. Glenn B. Gregorio, who will discuss the topic entitled Initiative on Sustainable Agriculture through Digital Agriculture and Mechanization. Ladies and gentlemen, please help me welcome Dr. Glenn.
Good morning to everyone, and I want to greet the Philippine Association of Agriculturists Incorporated for this second International Virtual Congress and the 2022 Philippine Agriculturist Summit with your very interesting theme, Digital Agricultural Science and Technology, Direction and Challenges. This is a very right time for us to talk about these things on what will be the future of agriculture in the Philippines and beyond. Now I want to talk about my topic assigned to us is about the big data, digital technology and public support services in the food sector for post-pandemic key enablers and policy actions. What I'll be doing now is I want to talk more on the details, specific topic on what are the initiatives on sustainable agriculture through digital agriculture and mechanization, especially what we are doing at CIRCA, and we will share to you some of the concrete examples of what we're doing on digital agriculture and mechanization. I will now share my slide. Okay. I think I'm now on my slide. This is my topic that I will share to you. I'll go to my we go to my next slide. I just want to inform you, for those who are agriculturists who are our participants, I want to introduce you a little bit of where I am talking. I am actually a professor at the University of the Philippines Institute of Crop Science under the College of Agriculture and Food Science of UPLB. At the same time, on secondment on loan, I am now the Center Director, or we call it the CEO of the Southeast Asian Regional Center for Graduate Study and Research in Agriculture. This Simio Circa was started in 1966. It's a non-profit organization. And this is our aim. The aim really of here during the time and up to now is to elevate the quality of life of agricultural farmers through sustainable livelihood and access of modern networks and innovative markets. This is where digital agriculture will come in. Okay, now we are now in our 11th five-year plan. We call it accelerating transformation through agricultural innovation. To make it short, you call it ATTAIN. So in the next years, starting 2 years ago, this is our aim to accelerate transformation through agricultural innovation, which is really in line of the theme of your of our, I will say, our second international virtual conference. Which is in digital agriculture, because accelerating transformation, this is where the digital agriculture, digital financial digitalization is very important. Okay, so again, CIRCA, our vision here is as a leading enabler and champion of excellence in agriculture and rural development in Southeast Asia, with the mission to elevate the quality of life of agricultural families, farming families through sustainable livelihoods and resilient livelihoods and access to modern networks. This is where digital agriculture will come in, and innovative markets. Okay, just to give you an overview what we are talking about digital agriculture, and this is moving every now and then. So what I'll just be showing to you is the reinforcing transformed agricultural food systems is actually to show that the present farmer make it to a new farmer, changing the mindset what farming is as a production into farming as a sustainable agriculture. I want to show you that to change the mindset, everything we have to change also that the way we're doing. We have to go to from value chain thinking or product-centric analog. We have to go to ecological thinking, market-centric, impact-centric, digitally transformed. This is where digital agriculture will come in, really, to make really ecosystem-based thinking, circular value chain. This is where we have to go for our to reinforce transformed agricultural food system in the Philippines and Southeast Asia. Okay, this is how it look like that we do not want our farmers to be just production or even just an agripreneur or business-minded, we want them to realize the transformation of our farmers would require innovative agricultural entrepreneurship, which we want to effectively do it. We have to use what is available resources, available technology. This is where the Internet of Things, we have to use all this to make it happen. So this is the present and this is the future. We have to have more on remote sensing, on crop management, Internet of Things application for climate smart agriculture, and a lot of things. So we are talking of big things here, but I'll be showing you later some examples, concrete examples that we are doing and what you are doing also. To make this happen, you have to think that this is not a simple thing. We have to look at it as an innovation for transformational change in agriculture. We need policy innovation. We need institutional innovation. We have the social innovation, technological innovation, and conceptual innovation. So these are the different innovation that we have to look to it. We have to look and we have to implement, because to make everything happen, policy is very important, infrastructure, inclusive of social innovation, technical innovation is always present. Of course, how we work together, conceptual innovation is very important. So at Circa, we have of course, our programs here. We have emerging, we have education and collective learning, where we give scholarship to develop our manpower and the human resources in agriculture. We have research and thought leadership. We do research for policy to support development. And of course, we have a new division, which I will say emerging innovation for growth. This is the crazy department, I will call it, where we do innovation, crazy ideas to make things happen. So I just want to introduce to you Innovates Together to Attain Agri 4.0. I'll just give you a slide, show you a slide now, or what a slide is, a video of what we are doing to make agriculture effective from the Innovates of the innovation, emerging innovation for growth department of Circa.
The evolving context of agriculture, rural development, and state of farmers as aligned with global goals focus on the contribution of agriculture to hunger and malnutrition eradication. Circa has embraced the rhythms of change with new innovative practices to transform the lives of farmers and the agricultural industry. With its mission to elevate the quality of life of agricultural families through sustainable and resilient livelihoods, Circa steers agriculture from the traditional farming production towards an agribusiness perspective in a modern agriculture ecology by accelerating transformation through agricultural innovation to attain Agriculture 4.0. The Circa Innovates model of open collaboration with academe, industry, government interconnectivity is a combination of independent but highly integrated component tool designed to attain sustainable development goals through Agriculture 4.0. A modern world transformed by innovative technologies, processes, and dynamics. The Circa Innovates component tools include Index, as the research and information arm of projects powered by the Circa Innovates model of open collaboration. Serves, specialists and experts for rural viable emerging solutions that identify and implement innovative but practical solutions to persistent farming challenges. Ideates, innovation competitions that focus on engaging the youth, children, students, and brilliant minds in promoting agri-innovation to modernize agriculture and build local rural innovation ecosystems. Blocks, building linkages and open collaboration for knowledge systems, is an innovative and open shared service hub promoting locally adaptable agri-technologies that can be adopted by small farmers and rural communities. A for Life, Agriculture 4.0 livelihood integration towards farming enterprises for building local and community-based innovation ecosystems and inclusive agribusiness value chains to produce a generation of green startups and agripreneurs. And Space, the Southeast Asia platform to attain collaboration and empowerment for a powerful innovation and open collaboration gateway for agri-incubation and technology transfer information, programs, resources, and networks in the world where Circa operates. Powered by Circa Innovates Model, the Emerging Innovation for Growth, EIG, as the new program in Circa's 11th five-year plan steps out from old ways that are no longer farmer benefiting to attain Agriculture 4.0 under three focus areas, namely open collaboration and agri-incubation, knowledge and technology transfer tools, and project development monitoring and evaluation. Circa partners to usher farmers out of the belief that farming is limited to production as an agribusiness operating in a modern agriculture ecosystem for better, bigger, smarter impact to farmers and farming families.
Get involved, spread the word. Circa innovates. If you're connected with a group that supports agriculture for farming families, we invite you to collaborate with our academe, industry, government partnership for better, bigger, smarter innovation. Together, let's attain Agri 4.0.
Thank you for, okay, so thank you for listening. So at least you have now the bird's eye view of what we're doing at our Innovates or Emerging Innovation for Growth department. This is the pathway to that. I'll not be going to the details of this. You can see from open innovation, co-enabler, we have to do engaged minds from our students, scholars, and specialists, experts, transformational innovation, which the solution is the outcome. We have the prototyping and startups, agripreneurship, agriculture and rural development, which we're looking for the impact, which we want to touch the farming families, rural communities. And of course, we go beyond Southeast Asia, Southeast Asia and beyond, and together we will attain Agri 4.0. And you will see here that we have also our, I will tell you a little bit of, we have now our sharing. We call it the Circa Hub for Agriculture and Rural Innovation for the Next Generation. So you will see the digital information, digital engagement, digital of the future of agriculture, and what are the existing technology in Southeast Asia so that you will be more encouraged, especially the youth, to pursue and appreciate agriculture. So this is just an example of our museum, Agri-Museum of Sharing, where we have digital. You will be amazed of how we will show agriculture through digitalization. And you will see here we have also our maker space and digital space for agriculture. So we'll show the new technologies, 3D printers, prototype of different tractors and soil types and all the technologies that is available. That's at the Circa headquarters in the UPLB campus. We have also a windows of the different technologies that we have, from food, from wine to tissue culture, golden rice, and other technology or packages of technologies for agriculture development. So I hope you could visit us, as we will be opening this coming August 15, and we will be open to the public. And we have also a Lego cafe where you will be doing some the theme of smart agriculture robotics, Lego robotics on agricultural development, or especially on smart agriculture. Now let's go to some of our projects that's ongoing. So we have digital agriculture platform at Circa, where we are partnering with UpGIS. This is an Circa initiative to modernize traditional farming and improve the livelihood of small farmers through digital agriculture. This is in partnership with UpGIS. These are a group of technology people who wants to develop the agricultural sector in the Philippines. And we are working in the farms of Mount Banahaw, where these are the vegetable farmer. I will show you later. So we are working in Nagcarlan, Liliu, Dolores, Quezon, in those areas near Mount Banahaw, and we are providing the cloud, and we will be empowering the farmers through digital agriculture, and I will show you later how it works. So this is how it works. We have two components of digital agriculture ecosystem. So the components on this digital agriculture platform one is the collection of farm data through cloud post and the Internet of Things, sensors on farm. We have the weather data, soil data, and photos of the plants. And the second part of this is the eco-commerce through AgriX platform. So the products will go to this e-commerce platform, the AgriX, which the farmers set prices, payment through PayMaya or GCash, delivery through Transportify. They call it Transportify, using the Transportify. So no middlemen will be engaged here. So farmers will be engaging to AgriX, and we will be delivering to the consumers. So this is where the farmers will be involved in the negotiation of their products. Okay, so this is the digital agriculture platform, which is the AgriX, where this allows a fair trade via farm-to-fork system, securing farmers their profit while serving fresh produce to consumers through e-commerce. So this is where the farmers will be engaged really and connect them directly to the consumers. So we have this digitally enabled agriculture platform services. They have online community, online store, farm management, virtual agriculture. So this is where really digital agriculture exchange platform for everyone, from farmers to traders to commercial to consumers. So how we'll do it? So we have to go to down level. We have to go to this courtesy call to the different village chief, barangay captains, mayors, vice mayors, even to the provincial agriculturists. So we have to touch base with them, let them understand that what we are doing is for the good of the farmers, and they are all excited to do this with us. Next, we have to have a farmers meeting. So we have to explain to them, give the confidence to the farmers that we are doing this for their own good. So we have to do a lot of groundwork to make this happen. Of course, the farm visits will be very important. So we go for farm visits and check their crops, check what they're doing, and engage the farmers as we are starting our digital agriculture. Then this is after that, we have to show them the vegetable packaging center. This is how we package. We have to have this carton. We have to do it in state of the art, something beautiful to show them that we are delivering their products to the consumers themselves. And this is how the AgriX put their products into 7.5 kilos per box, different products, and deliver it to the consumers through AgriX. Of course, so that's what we're doing for them. We are helping the farmers in Mount Badahaw. We are giving them tablet to input all their cultural management, time to harvest, so that we could synchronize the harvesting and the packaging of their products. So I could give you more details next time. And if you visit us, now I'll be talk about Innovation Olympics, also what we're initiating. So this is a national competition challenge for the next generations of university agri startups to develop innovative solutions to help transform the food and agriculture sector. So we're engaging the students and we are partnering with the private industry, especially the East-West Seed Company, Tencent, and we are involving also, of course, the UPLB to help us on this one. So we have the theme on precision agriculture for small-scale vegetable farming, and we just finished this Innovation Olympics. We have our 6 finalist teams. Out of the 21 teams were awarded 100,000 pesos or almost $2,000 as seed money to implement and adapt or to pilot their project in the communities. And they are already winners, so we have awarded 100,000 for them, but they will be having the grand finals. So the grand finals was last year in October 2020, and we are giving them 250,000 for the grand finals. So we have 6 finalists, and the awardees are, we have Thai on the grand champions, that is the Team Irene, which they have automated irrigation and nutrient management system. And the other is the Project Angat, which they develop hydroponics. So this is what they're doing on Innovation Olympics, on how to help farmers. So we are engaging the youth through digital or solar system to help them in irrigation. And the other one is the hydroponics using the bamboos. So this is just examples of the innovations or the crazy ideas we are doing to engage our students to help the farmers using their ideas. I want to introduce also to you this agri-mechanization through tractor development. So this is like an open source tractor to increase agricultural mechanization in Southeast Asia. This is co-developed and scale out for open source innovative tractors suitable for sustainable farming. So CIRCA has partnered with Kansas State University and UPLB Center for Agri-Fisheries and Biosystem Mechanization. So we have a lot of partnership to bring this. We bought this tractor and bring it to the Philippines, and we have to develop it in the Philippines and engage those who are the manufacturers of these tractors to make it happen. So this is the Ogon tractor we bought in the from US and send it here, and we get the expert from US to make it Philippine made. And actually we have already this agricultural mechanization through tractor development. They develop from our tractor manufacturers in the Philippines. They develop our locally grown tractors using that model because it's open source. And we use that in the models to engage the students. This is just an example in our museum. We have those models, and the students and anyone could assemble it in this in a small prototype. So this is the tractor that I want to show you, that the first Philippine-made 4-wheel tractor patterned through this Ogon tractor that we bought from US. So we are happy that it's already working. It's already here in the Philippines, and we are manufacturing it. And this is how it looked like. We are giving them the patent. It's very easy, so we don't need to buy a very expensive tractor, but Philippine-made, designed in US, and shared to us the blueprint. Okay, so I will not talk more on this carbon farming project that we are doing also. And just to end it, I will just answer some of your question later. I could not give you all the details of this because I have limited time. I just have the message that the reality of innovation or digital agriculture is won or lost at the farmers and consumers level, where applicability and sustainability is tested. So we have a lot of prototypes, but once you put it in the farmer's field, once the farmers will be adopting it, that's where we say it's working. Again, Thank you very much, and I'm happy to answer some of your questions. Thank you very much.
Thank you so much, Dr. Gregorio, for a very clear presentation and also emphasizing the Agriculture 4.0. Now we are ready to some question or clarification and suggestion for the discussion of Dr. Gregorio. Anyone from the participants? Sir, there's a question. We had just concluded our Mindanao Congress Summit last February of 2022. And part of the discussion was really the digital agriculture. However, there are so many problems along the line. Now, all agriculture related government agencies have their own plans and programs. At the same time, all others, but the problem now is how to harmonize all those things so that we can have a holistic approach to be implemented in the local government units. Please, your comment, sir.
Yeah, that's a very good morning ulit sa lahat. That's a very good comment. I know everyone is doing their own. The question is how to integrate them into one. So my suggestion is I hope maybe the DOST, the DA, the DAR, and all the other agencies, we should have a center of excellence of this one, because we have to synchronize everyone, and we don't need to reinvent the wheel. So I think that's the message now. But as of now, we are encouraging everyone to do their own, because they have their own ideas, develop, compete together, parang payabangan, to show off what they are doing. At the same time, someone should be there to integrate. We must have a center of excellence, or it might be a university, a hub that will showcase. Shirka, we are doing our own also with the digital agriculture, where we are not just talking of ideas, but we are doing it in actual, working with the LGU, working with the technical team, and show that these farmers from the Banahaw area could be taught. We'll be giving the tablet, we have tablet, we have the iCloud post, and put their information there and link them with the market. And it's working, starting working. Even during the time of pandemic, we have made it, and a lot of farmers are starting to come in to join because they realize the importance of it. Actually, we are UpGIS, AgriX, and Circa is approaching now the government, slowly showing them this is a prototype that is doing well, and the farmers are benefiting because we put solar panels there, and we put also some internet, because these are farmers in Mount Banahaw. They don't have access on this one. We are helping the farmer. At the same time, the good thing is that the children of the farmers who are more techy, they help their parents who are farmers. At the same time, they are using that internet also in their school. So it's a win-win approach. Everyone is going up, very inclusive. And this is where we could be one of the center of excellence, or any university or any hub center of excellence to do it. So it's just a matter. I hope the new administration, I know they are very keen on this, and we should start with this one. At the same time, the rest should do it also. Just using your cell phone, using the GCash. So we're starting doing the digital agriculture. If you're a farmer, you don't need to go to your field right away. They will show you the video of what's happening right now. You could even see the disease, and you could advise what will be the best remedy, or whatever intervention you will do to avoid those diseases. So those are the starting points. So you don't need to be very high tech using drones and all these things. Using your cell phones, using digital GCash or PayMaya to do things, then that will be a good set. At the same time, mechanization. Thank you.
Okay, thank you so much, sir. So I do hope with the new administration, this best practices that you have started will be replicated to the other localities in the whole country, sir. Yeah, because this is now the trend of extension services to the farmers. Sir, there's another question or comment here. Looking forward po sa digital program na yan kasi po dito sa amin middleman ang nakadictates ng price sa mga farmers. Kawawa po sila. Any comment on that, sir?
Yeah, that's why we are packaging. That's why we have this. We call it the digital agriculture, and we partner it with also we call it the AgriX platform, where farmers could set the price, payment through Paymaya, deliver by Transportify. We call it a modern way of delivering, and no middlemen. So they will directly receive the money through GCash or Paymaya. So this is the beauty of it. But at the same time, we should not. We should encourage the farmers to be the middlemen or the traders. These are very important component of the value chain. So we have to encourage them to be more digital, so that the farmers will have an access which has highest bidder. So who has a highest gate price, then they will deal with them. So that's the beauty of this one. For digital agriculture, we are not only on the production side, but also the marketing side. So the middleman will start to modernize themselves to compete with this AgriX that we are doing. So this is the beauty of what we are doing from Mount Banahaw. They go to Manila or Laguna area to the municipalities, and the consumers will know from where this harvest came from farm of Gregorio with the soil type harvested last month, this variety. So while they're eating their food, they know the trait, who is the farmer. So it's beautiful. It's nice to eat food that they know when it was harvested, what's the fertilizers they use, and all those information. Barcoded na rin yung mga pagkain nila. So, but as I mentioned, that we have to take care of also for our traders. Pag naging kompleto na ito, baka ang traders na natin ngayon ang maging poor. So we have to help them at the very start also. But because they have a very important role.
Yes. Thank you so much, sir. No? So meron na tayong traceability sa ating pagkain.
Yes.
Okay, sir. Another comment from Jonathan. Wow, pwede na itong ipakita sa mga Key-12 students, Key-12 students to encourage more students to go more on farming.
Yes, and as I mentioned also in my presentation, we will be opening this August 15, or we call it Shirka Hub for Agriculture and Rural Innovation for the next generation. So we have a digital museum, we have a digital agriculture part there, we have a digital space, we have demonstration of the modern agriculture, and we have the Lego Cafe, where children, even the parents could play with their kids on robotics, on agriculture, on smart agriculture. So we want to, as early as possible, they have to be enticed. So this is just an example. I hope they could visit also Circa, so that they will be encouraged to go to agriculture, digital agriculture or digital food systems.
Okay, thank you, sir. Another comment, sana all talaga supported ng LGU ang digitalization ng agriculture para increase din ang agriculture produce in the locals. Yeah, I think that's a follow-up. Yeah, okay. Another comment, sir, magkano po yung tractor, sir?
Very good comment. Ngayon medyo hindi ko pa mabigay kung magkano ang tractor because prototype pa lang ito. It's now the original is about $10,000 to $15,000. But now we made it locally because naging pattern natin yan. We are building it locally. Nagawa na yan sa Negros. They made it the prototype. Meron silang apat. One is already working. And dahan-dahan na yan. Everything will be locally made. So that's the beauty of this tractor. And I could not give you the exact price, but it is much cheaper in buying this tractor. We want it local tractor. Hindi na tayo kailangang bumili sa branded. Kasi the beauty of this one, kahit babae, ay kaya mag-drive nito or walang hindi marunong mag-drive. Kasi you just press the accelerator, it will run. If you release the accelerator, it will stop. So ganun din siya kasimple. Talo mo pa ang bisikletang pag-drive ng bisikleta nito. Kaya cute siya.
Okay. So in line with that, sir, there's a follow-up question. I am very interested on the prototype tractor. How does it cost? Can we have the contact address where we can order perhaps in the future?
Yeah, so what you do is I don't have the contact address with me from the tractor. You could send me an email through Circa. Then we will connect you to the tractor owner in Negros. Yeah, Negros, and now it's now in Palawan also, and now in UPLB also. So we will contact you if you're interested really. So we could give you the address. So send me an email or send email to Circa, and it will be forwarded to me initially.
Okay, thank you so much, sir. There's another question from GJ. Sir, yung Agriculture 4.0 project nyo sa Banahaw, pwede na po daw ma-adapt sa amin? What are the salient features?
Yeah, pwedeng ma-adapt yan kasi ito ay prototype lang. So what we are showing here is farmers. We could organize the farmers from Banahaw area, which is Nagcarlan, Lilio, Dolores, Quezon, Mayhay. These 4 areas, we are showing that walang kuryente doon sa area na yon. Walang internet, but we were able to install these internets and cloud posts sa area na yon. So what we are showing here, that it's starting to be successful and many farmers are coming in, then we could scale it out. That's the model we want. We are approaching now the management, the new administration, because this is their focus, and we are showing that we are not just talking about digital agriculture, we are implementing it. That's why we showed you how we started it. We engaged the local government. We talked to the mayors, and they're interested. We talk to the barangay captains, or kung sa tribo man sila, then we talk to the farmers. So ganon dirty job in doing it. So people are now looking at that projects, and now, as you are saying, we could replicate it in your barangay with the support of the local government, because the Bandanas ruling now, they have more than 30% more budget. So you have to talk to your mayors, you have to talk to your governors, because the money is now not in the central government, it's now going to the local government. So it is an exciting moment actually.
Yeah, it's true. Sir, another comment or question from Facebook user. Doc Glenn, we would like to ask how you can help reach the private sector in agriculture who has constraints in digital agriculture, especially in rural areas. What are your programs in order to materialize this platform?
Yeah, if you're talking about private sectors, iba yung meaning niya ng private sector dito. Private sector siguro yung mga private farmers or small businesses or not yet, because the private sector, you're calling about San Miguel, you're talking about East West Seed Company, Monsanto. These are big companies that they are already performing this digital agriculture. But if you talk about a small businesses in agriculture na wala pang mechanization, so we should, as I mentioned, we should have a center of excellence of this one. So it should be the universities who will be having a hub of digital agriculture to show what are applicable in your area, because digital agriculture ay hindi mo makokopya lang yan madalian. You have to customize it in your location, in your soil type, in your crop, in the culture of the people. So if the culture of people is not yet ready, so you start with mechanization, you start it with simple as GCash, messenger, you're using that for your digital agriculture. So we at Circa, we are enabler only, enabler. We want to spearhead. If you are really interested, then because wala pa tayong mga hub ngayon for digital agriculture, visit our hub at Circa. Then if you have project, we could project with your local government, then we could implement this kind of work, because we want to work with the private sector, because they are the drivers. Madali silang mag-adapt kasi they mean business. That's why I'm emphasizing that agriculture is not only production, agriculture is agribusiness. Look at the whole value chain to make this happen. Thank you.
Okay, thank you so much, sir. Now, I would like to fuse the three questions in the Facebook, coming from Facebook and Eric and Fe. The question goes this way: how many horsepower is the tractor? Can we access the blueprint of the tractor? When will the tractor be available in Mindanao?
Okay, so let's make this happen. Just send us an email, then we will send you the information about this tractor, and we could give you the contact and even the blueprint, and we will have to engage you more. It will be nice if you could visit us or send us an email, then we could talk about this one. I'm not an engineer, I'm a geneticist. I could not give you the specific horsepower and all the specifications. I think you could even, if you could initially get my slides. If you want in PDF file, I give the authority to PAA to share my slides. You could see some initial information there. I showed you the different components of the tractor, and send us an email, so we will talk to give you the details on this one. And I'm happy that this is an open source tractor. The patent will be available to everyone with a limited price or a contract to make it sure.
Okay. Thank you so much, sir, for your time and expertise of sharing to the Philippine Association of Agriculturists. Kung wala ng mga tanong, may I please read the certificate of appreciation to Dr. Gregorio, please?
Ma'am, there is a question po.
Sir, can we have your Circa email?
Yeah, ipopost na lang nila. You could have my advice is go to the website, and we have a Circa post there. I will not give you my personal email kasi baka ma-flood na ito. But with that Circa post, darating sa amin yan, surely. Just go to our website. You could even see the Ogon tractor there, and contact us. For that matter.
Okay, thank you so much. Sir, salamat sa lahat, for sharing your time and expertise, and we hope that Circa can help a lot in the Department of Agriculture, particularly on innovations. Okay, I will read now the citation. Certificate of appreciation is presented to Dr. Glenn B. Gregorio for sharing his expertise and knowledge in his paper entitled Initiatives on Sustainable Agriculture Through Digital Agriculture and Mechanization, given this 23rd day of July 2022 during the second International PAA Virtual Congress and 2022 Philippine Agriculturist Summit. Signed, Roberto F. Ranula Jr., BOT Chairman. Signed, Loe A. Divina Gracia, PAA National President. A big hand for Dr. Glenn Gregorio.
Thank you. Sa uulitin.
Yes, sir, of course. Okay. So salamat, sir. Now let's move on to the fourth topic, and this will be discussed by an associate professor of the University of the Philippines who is an environmental science Doctor of Philosophy, and an expert on environment and GIS. And his topic to be presented this morning is entitled Open Data and Tools for Agricultural System Analysis. Ladies and gentlemen, please help me welcome Dr. Arnold R. Salvacion. Sir, good morning.
Hi, good morning po. Magandang maga. Good morning to all of the audience. I'll just upload my presentation. Malinaw po ba yung dating ng
Yes, sir.
audio and video? Kasi may
Yes, sir. Clear and loud.
may renovation kasi sa ibang kabilang bahay, so baka marinig yung how do I present this? Okay, good morning everyone. So for this morning, I'll be discussing about the open data and tools for agricultural systems analysis. Again, as mentioned earlier, I am Dr. Arnold Salvacion from the Department of Community and Environmental Resource Planning, University of the Philippines, Los Baños. Can you move the slide, please? Next slide, please. Okay. So for the outline of this presentation, so first I'm gonna give a brief background or overview of what is agricultural systems and agricultural system science. The next is what are the initiatives around the world on the open data and open tools. Then I will try to provide some of the tools and data for agricultural systems analysis. So most of these tools and data are what we have used or have implemented in our previous research project, and then provide some case studies in the Philippines and some concluding remarks. Next slide, please. Okay, thank you. According to Jones 2016, according to Jones et al. 2016, agricultural systems is a collection of components. This could be natural or the natural environment, the weather, and human influence. This could be the interventions that farmers do, the policies, and other human influence factors that affect the overall system on producing crops and raising livestock for food, fiber, and energy. While agricultural system science is an interdisciplinary field that studies complex agricultural systems. So, as I know, our agricultural curriculum, we don't just took subjects on agriculture, but instead we also took courses on economics or engineering, so that we could study the entire agricultural systems. Next slide, please. Although we could study agricultural systems under a natural or precondition, sometimes or most of the time it could be impractical or impossible. So this is an example of a soil erosion hotspot study that was being done by Dr. Ed Panning-Batan from UP Soil Science Department before. So as you could imagine, it would be easy to do soil erosion study on a field plot, but doing it on a large scale or a watershed level would take a lot of manpower and man hours to assess the erosion hotspot. But for this one, using models or open source tools, you could do this in even less than a day. Next, please. So this is an example of a farm information management system. So I just want to show here that the different information the farmers or farm managers considers in order to produce crops or livestock. So as you can see, there's a lot of information, there's a lot of actors, there's a lot of factors influencing this. So, and when you talk about information, you cannot discount there the the data that you need to to analyze or to evaluate in order to provide a sound decision for your farming systems. Next, please. So open data tools and initiative. The first one I'm gonna talk is about the Creative Commons. So even though we're not aware of, some of you are not aware about the Creative Commons, but it has already existed for this year. They're gonna be celebrating their 20 years anniversary. So next slide, please. So Creative Commons is a nonprofit organization that helps overcome legal obstacles of sharing knowledge, creativity, and creativity to address the world challenge. For example, the one that Dr. Gregorio is presenting earlier, the tractor. I don't know if it is as a Creative Commons because Dr. Gregorio said that the tractor design is on open source. So if it's open source, maybe the details or the design of that tractor is licensed under Creative Commons. So there are a lot of license agreement or license scheme that Creative Commons provide. So this could be, for example, for your copyright, for your design, for your data, for the results of your study, you could also use Creative Commons. But I'll just talk about the three common ones. The first one is Creative Commons BY, or the author or the copyright owner only want attribution from their work, so they don't require monetary benefits from their work. The next one, go back to the previous slide, please. Previous one, please. Okay, thank you. The BYSA is that any work or any data that being shared through Creative Commons or any derivatives. For example, the tractor that, again, let's go back to the tractor. The design of the tractor, any derivatives of that, the user is required to share it with the same copyright agreement that the owner provided. For example, if they share it under common Creative Commons attributions and share alike, so the author or the one who would do the derivative, for example, they modify the design of the tractor, so they have to share it also under this license. So they are they're not allowed or to use it. For example, they're not allowed to use it or to provide other schemes under these terms. The last one, or the third one, is the Creative Commons BY and NC. NC means no commercial use. So you could provide your data, that you could use their data, the authors could give you your data, their design, but you are not allowed to use that design or to have profit or to make a product that you could make profit out of it. Next, please. Next slide, please. So the next one is open tools initiative. So if you have the data, so then you need the tools to analyze them or to process them. So the open source initiative, this is a also a similar to Creative Commons. It's a, next slide, please. Is a nonprofit also corporation with a global scope formed to educate about and advocate the benefits of open source. So it builds the bridge between the open source developer or among constituencies. So these are the developers and the users. So they're the one who's promoting it. So the platform. So they also the one on the licensing. So these are the one that they are working on. So next slide, please. So for the open source initiative, a software could be considered open source based on the following criteria. They have a lot of criteria on their website, but I just put here only the first three criteria that they presented there. The first one is the license, a pre-redistribution. So any users could download it and have no restrictions of copying it, modifying it, and giving it away, and even making profit out of it. Okay, so next, please. So the next one is the source codes. If you're doing an open source initiative, you're joining this initiative, you also need to provide the source code or the command lines that are used or being compiled to run your software or your program. So it could be publicized, but or you could publicize the way that the users or any interested party could access the source code, because the software that you're sending, they cannot modify it anymore unless you give them the source code. So the mode of obtaining the source code, they like it to provide it via internet downloads without charges. That's why it's called open source initiative. Next, please. So Derive works so under OSI initiative. So you must allow the users or the users of your software to distribute it under the same terms the way you use it. So these are some criteria that you have to follow if you want your software or tools to be licensed under open source initiative. Next, please. So the open data for agriculture and systems analysis. So these are the available data online. These are not exhaustive. Again, as I mentioned earlier, these are what we have used so far in our research projects. Next slide, please. The first one I'm going to discuss is the word claim database. So for those who want to study climate, the impact of climate on the agricultural production system, you could use this word claim database. Next slide, please. So they have historical data, they have historical monthly weather, and they have future climate data. For these are may be of interest for those who will do climate change impact assessment. So they also provide those data sets. Next slide, please. So you could go to their website and you could easily download. These are the links. Those lines, that those fonts are colored in blue. Those are directly connected to the links where you could download the data sets. So they have from 1960s, I think, to the 2018. I hope they already have uploaded it for the 2020. Next slide, please. Again, as I mentioned earlier, they also have future climate data. So if you want to do impact assessment on the effect of climate for agricultural production system or crop production or animal production, you could use this. You could go to this site, and they have, I think they have at least 9 regional climate models to provide future projections for 2021 to 2040, 2040 to 2060, and then and so on and so forth. So they have variables as like monthly minimum temperature, monthly average maximum temperature, and then maximum precipitation, and lastly the bioclimatic variables. These bioclimatic variables are mainly the combined or the analyzed data sets or derived data sets from this temperature and rainfall data. Next slide, please. So if you want to, the good thing with the open source data, they have well-defined or documented publications on how they derive the data sets. For example, for this one, this even is a peer-reviewed journal article on the description on how do they derive the word claim data sets. So as you can see on the citations, we can say that this is one of the mostly used and mostly cited, I think, the data set that is available. As of now, they have more than 12,000 citations. Just imagine, for a single article, you will generate 12,000 citations. So just imagine the impact of your work. Next slide, please. So this is another peer-reviewed article or journal about the World Claim Database. So they updated in 2017, and you could also read this, so you could know what are the revisions that they have done, or what are the updates or corrections they have done to the current versions of the datasets. Next slide, please. So the next dataset that I will discuss is the CRU datasets, or Climate Research Unit datasets. So this is high resolution also with the datasets, which is produced by, next slide please, by the University of East Anglia. So it's a resolution of 0.5 degrees, so it's approximately 40 or 50 kilometers grid size. This compared to World Claim Database, CRU dataset has a lot of data set available for it. So you also could download cloud cover, the urinal temperature range, frost day frequency if you're working on the temperate regions, the PET, the potential evapotranspiration, also the vapor pressure and the wet day frequency. So this is from 1901 to 2015, but I think they only lag at least 1 year period. So for 2022, I think if you check on their website, I hope they have data until the 2021. Okay, next slide, please. So this is the peer-reviewed article about the CRU datasets. So you could download this. I think this also an open access article, so you could study more if you're interested how they derive the datasets and what are the datasets or are the input data that they use to develop this database. Next slide, please. Recently, they also published an article on the version 4 CRU dataset, so you could also download this. Again, there are also now journals, peer-reviewed journals that are specialized on presenting datasets or describing datasets. For example, for this one, this is under Springer Nature Publisher, so they have the scientific data journal. So this journal caters to all those datasets or description of the datasets published, which the authors would like to share with other people or other researchers. Next slide, please. But for when you want to download the CRU datasets, you have to create an account under this the website of Center for Environmental Data Analysis. So you have to make an account before you could download these datasets. Unlike in the World Claim, you just go to their website and then you could easily download it to your machine. Next slide, please. So the next dataset that I will be discussing is the TerraClimate. So this was published or developed by the Climatology Lab before connected with the University of Idaho, but I think in 2020 they moved to the University of California, Merced. Next slide, please. So TerraClimate is a monthly data set. This is from 1958 to 2019. Again, I think this is similar to CRU data sets that they only have 1 year lag period. So I think they already have updated data set for 2021 at the moment. So they have these are the primary variables or climate variables if you want to use them. So they have maximum temperature, minimum temperature, precipitation, vapor pressure, accumulation, downward surface shortwave radiation. So I think you could convert this to solar radiation, for example, for those who's doing crop simulation models, or and then lastly they also have wind speed. So those who want to study the effect of wind speed on power production system, so could use this. The good thing with the TerraClimate, they also have those derived variables. For example, you don't need to compute for the reference evapotranspiration, so they have done it for you using the Pontit method. Then they could also Penman-Montit method, sorry. So they also have data sets on runoff. They have data on actual evapotranspiration. They also have data sets on water climate deficit, soil moisture, snow water equivalent. They also, for those who's interested in studying the effect of drought, so they also have data sets on Palmer Drought Severity Index and then the vapor pressure deficit. Next slide, please. So this is the description or publication on the description on how TerraClimate was developed. So again, this is published under the Scientific Data Journal of Springer Nature. Next slide, please. Okay, so when you go to the Climatology Lab website, you could easily download under the download tab. You just click the download tab, and you could get data for individual years, for aggregated years. They also have data for individual years plus 2 degrees Celsius. So if you want to, again, as I mentioned earlier, do climate impact assessment, then individual years plus 4 degrees Celsius, and then they also have climatologies or what we call normals. So these are average of 30-year periods. For example, for this one, 91 to 1990, 1981 to 2010, and so on and so forth. Next slide, please. Okay, so enough with the climate data. Let's now move on with the soil data set. So this is the soil grid or the soil grid data set. So it's a digital soil mapping based on global compilations of profile data from WOSIS database. So it's from ISRIC, it's the International Soil Information Center. So the hope of this data set is to provide a globally consistent data-driven system that predicts soil properties and classes for the entire world. So next slide, please. So they provide physical and chemical and other derived soil properties under different depths. For example, from 0, 5 to 100 and to 200 meters, centimeters depth. Next slide, please. Next slide. So this is an example. I just tried it to show you how to explore the website. So this is, I think, I put it somewhere in Marinduque Island, Philippines. So I just put in, when you click on the map, in the part of the map, you could explore the data. So it will show you the data set available. For example, for this one, for physical properties, the bulk density and the clay content. So it already gives you the values at 0 and then at different depth. So then I think you could click to the right and then the chemical properties. And then if I think you're okay with this data set or you want to explore it, you just click this download button, and then a map will be downloaded to your machine or to your computer. Next slide, please. So this is the publication describing how the soil grid dataset was developed. So it was published by Hengel et al. 2017. As of now, they have also already a lot of citations. Next slide, please. So last year, I think they updated the soil grid dataset, so 2.0. So this is the paper that was published by Fojo et al. 2021. So on the description of the updates or the corrections or revisions they have done to the database. The good thing with this publication is you could really see how robust the database was, how the database was developed, and also you could see the uncertainties. So you could, of course, these are not an exact measurement or a true to measurement data. So they also provide you some uncertainties. Next slide, please. So another worth noting database is the 10-kilometer global resolution soil profile data for crop modeling. I don't know if there are audiences here who are familiar with the DSAT crop simulation models, but this soil profile data is developed to cater for those who's gonna use a DSAT crop simulation model. So because it's really hard to to get soil profile data and format it or modify it or format it for the use of crop simulation model. So just imagine you have to go to the field, you have to do sampling, then you have to do analysis and all of that, And this is not only true for one field condition. So if you have multiple soil classes, so you have to do at least analysis or multiple sample for each soil classes. So just imagine the amount of effort and the money you need to spend to generate those data sets. Next slide, please. Next slide. So the 10-kilometer global soil profile database, they host it under the Harvard database, Harvard Dataverse. So as you can see, as of now, I think they have more than almost 6,000 downloads. So it means that there are a lot of individuals or researchers trying to explore or maybe use these data sets. Next slide, please. So let's now move on to the open tools for agriculture systems analysis. So you have already the data. So of course you need the tools to process or view this data in order for you to use it for your for example your targeted or specific needs. Next slide, please. So one of the open source I was talking earlier about crop simulation models is the AquaCrop OS. So it's a open source crop simulation models. Next slide, please. Yeah. So AquaCrop is a free and open source AquaCrop model because before AquaCrop was developed by FAO, so you could download the software on FAO website, but now I think they also have their own website. Is the aquacropos.com, where you could download this, and I think you could also request the source code of this one, so you could modify it. For example, your crop of interest is not parameterized or not available on their system. You could, if you have the data sets, you could modify this source code to fit your crop of interest. Again, for those who are, I don't know if you're familiar with GitHub. If you search on GitHub, you could actually see the source code or the lines of codes that simulate simulate all these yield responses of different crops under multi-environment. Next slide, please. So if you want to download, want to see this scientific paper or a brief documentation about AquaCrop OS, so you could download this paper by Foster et al. On agricultural water management. Next slide, please. So the next one is the GIS software. So the maps that I mentioned earlier, the climate maps, the CRU dataset, the WorldClim, the soil grid database, most of them you cannot just view them using the standard Windows or any operating system software. So you need a GIS software that could read maps. And one of the most common, and I think this one of the most popular open source software is the QGIS or software. Next slide, please. And the good thing with this, as I forgot to mention earlier, the good thing with open source software is it doesn't matter what operating systems you are working in. So it's either you work on Windows, you work on Mac, you could still use this or install this operating system, because I know some of the software on crop simulation models or in GIS that you could only use them for Windows database or for Windows operating system. But for QGIS, you could use it even at different operating systems. You could even use it. I think this is, if you have Android device, you could download it directly to your Android device and install it. So unlike before, when we do field mapping, we have to bring GPS, and then from GPS we have to download a software that could connect the GPS to computer, and then from that on we could extract the data from the GPS, and then from that software we have to transform it to a GIS readable data, and then put it in a GIS software so that we could produce the map. So if you download it directly to your mobile or tablet, just imagine the number of steps you could skip and have readily available GIS maps or digital maps for your analysis. Next slide, please. So this is the interface of QGIS environment. So you could see the map here. And then there's also different tools or functions that you could do or that you could use to analyze your maps. Next slide, please. Another open source tool that I would like to discuss, and I think this is also gaining gaining traction on the open source field, especially in data analysis, is R. So R is a language and environment for statistical computing and graphics. So the good thing with R is you could also process those database or those maps under this software. So and then unlike before, when we download data from the field, so for example, so with GPS, or as I mentioned earlier, and then put it on a GIS map, and then when we have to do the statistical analysis for our data sets, we have to transport again the data sets into statistical software readable file. For example, the statistical software like the likes of SPSS and SAS. So we have to move from one system to another to really analyze our data sets. Unlike in R, you could do all the mapping, the visualization, and even the statistical analysis in just one software environment. Next slide, please. So, like other open source system, R is also available for different operating systems. So, if you're using Linux, you could download it. If you're using Mac, those Apple users, you could download it. And those who are using Windows, you could download it. Next slide, please. This is the native R console or CLI or the command line interface. But next slide, please. If you want to study it, there's a IDE or what they call the integrated development environment where you could test or run your code or write your code easier and visualize the results immediately. So this is what they call the R Studio. So this is the one that mostly they use to do the analysis or mapping or even plotting or creating these graphs for scientific purposes. Next slide, please. So this one I'll use is a package of R. So this system is developed for targeted for our environment. So this is an R package that evaluates suitability. So if you have data sets, for example, you download WorldClim data sets for the climate requirement of the crops, and then you download the soil grid database for the soil requirements of the crops. Then download other necessary landscape features, so you could easily evaluate the suitability of a particular crop in a given location. So using this one. Next slide, please. So this is the peer-reviewed article which is published on the Journal of Open Source Software. You could download it so that you could see how RUse how RUse is developed and being maintained, or where you could download it. And then also for those who have GitHub or I don't know, you could just check the source code. We publish the source code for this one, so you could see how the software or the system calculates suitability for different inputs. Next slide, please. So for some case studies, again, as I mentioned earlier, I'll try to provide some case studies so that the audience could know or could see that these data sets could be used or have been tested, and there are research papers published on utilizing these data sets. Next slide, please. So this one is published on 2015. So this is on the assessment of mycotoxin risk on corn in the Philippines under current and future climate conditions. So here we use WorldClim database to estimate the potential distribution of aflatoxin under future climate condition in the Philippines. Next slide, please. So the next one, for those in Isabela, so we also did a study with Dr. Jong Martin of Isabela State University on the effect of climate change on corn suitability in the provinces, on the province of Isabela. So as you can see here, as we move to the future, there's a decreasing trend, and I think this is on temperature rainfall suitability or temperature suitability in Isabela. Next slide, please. So for this one, effect of climate on provincial banana yield data in the Philippines. For this one, we use CRU data sets along with the published banana yield data by the Philippine Statistical Authority. So we do some regressions to estimate what is the impact or what are the factors that affect the banana yield in the country. Next slide, please. So this one on the CSI, those familiar with CSI, we did a study 2 years ago, but this was published just last year ago on the extent or the possible potential risk of CSI if introduced to a specific location in the country. As you can see, these red ones are those areas with high potential, or the environment for these areas are suitable for CSI. For this one, I think since this is on the collection data for CSI is on a yearly and monthly basis, so we use the Terra Climate dataset to match the CSI collection datasets or the reporting datasets. Next slide, please. So this one is the last, I think that is the last slide in mapping land limitation. So instead of mapping the suitability, we did the reverse. So we mapped the limitation. So what are the potential limitations, mostly environmental limitations, that could impact, I think this is a coconut production in Marinduque Island. So as you can see, you could easily, or for example, the MAU or the farmers or even the policymakers could easily see what are the limitations on these areas. So they could easily get it. So if the green, there's no limitation, and if it's red, so there's at least 3 limitations or multiple limitations. So there's a rain, slope, and soil limitations. So again, with this information, you could do a targeted, or you could easily provide a more specific production systems, for example, soil technologies for the farmers in the province. Next slide, please. Yan. For the concluding remarks, so there are data sets that could be utilized to analyze different components of agricultural systems, and there are open source computing tools that could handle and process these data sets. Because normally that would be the problem. If you have these data sets, how do we analyze it, or how we view it, how do we store it? So there are also open source computing tools that could handle this, because sometimes this could be limitations, especially for those startup or those LGUs with no capacity to buy software, because we know software, commercial software, they don't just cost us less than thousands of pesos. Some of them cost hundreds of thousands of pesos. So instead of putting the money on the purchase of the software, you could just use it to maybe to collect more data or to hire more people. And then there are also platforms and ways that researchers could share our data sets. I think this should be the next norm in the Philippines, where we could share our data sets so that we avoid duplications, and also we could help especially those budding researchers, the starting ones, on their research, especially if they're just starting and for example, they don't have a track record or a big funding, so they could at least start small projects, so where they could just showcase their skills and their project management potential. So that later, when they ask for fundings for funding agency, they could provide a track record. You could say, oh, I already did this analysis, I already published a paper on that topic. So that could attest that they could hopefully successfully complete a research projects. And lastly, our part as researchers is to maximize the utilization of these data sets. There are a lot of data sets, as what mentioned earlier by Dr. Dr. Glenn Gregorio and Dr. Roger Concepcion. So if the wheel is not broke, you don't have to change the wheel. So you could maybe repurpose the data sets, because even though the data set is collected for other purposes, I think we could repurpose it to answer other research questions. I think that's all for this morning. Next slide, please. And thank you very much for your attention.
For a very comprehensive and informative presentation. Now let's move on to the question and answer, sir. So the first question is from Jeff. Can this site prove climate data on a specific location? Let's say in a certain farm in a certain barangay.
Yes, you could download it. They could provide information. Actually, this dataset could provide information for the entire globe. You could just extract the specific, for example, as what you said, town or barangay. Yes, you could do that.
Okay, that's very good. No, so specific location specific, right?
Yes.
Yes, sir. Okay. So, question from Gigi. Paano ma-update ng knowledge namin? Ano po ba ang course na inaaral nyo for that?
Okay. So I think you could I think these topics you could easily study this on the internet with the modern age of the information age, or the MOOC. You could try the MOOC or the massive open source course. So you could check that if you want to learn more about GIS, or you want to learn more data analysis if these are not part of your curriculum. So you could just you could check there's Coursera, I think there's EDX. What are the others? I think Udacity or Udemy. There are a lot of materials that you could study. So I think you don't need the course for this one. But if you want to dig deeper on the science of these techniques and tools, so that's when you need to study a course for it.
Okay, thank you so much, sir. So another question from Ronald. Your project is very useful, especially for us doing soil survey. My question is, were you able to validate the reliability of that model?
The soil grid database, it has been validated for the entire world. So I think Philippines is also a contributor to the WOSIS database. So have not validated it yet in the Philippines with the new data sets, but I think this has been validated with whatever the BSWN or our soil bureau have contributed to the World SIS database, because this data set is derived from the contributions of the different soil bureau from the entire world. So, for example, for the Philippines, I think we have BSWM have a database on the different soil characteristics of the Philippines. I think they contributed it to the WOSIS database, and then these researchers include those data sets to develop this. But for the Philippines, if you want to do, I think you could also do the validity. But I think if it's a peer-reviewed journals, in general, there's a validity or robustness to that to the database.
Okay, thank you so much, sir, for that answer. Now, another question from Andrea. Is there a list of all open data sources that we can visit, use where climate data such as rainfall, temperature, and other data related to soil erosion, such as soil characteristics, can be downloaded for use in the further analysis? I mean, complete list where every open source information is listed. I've already listed what you have represented, sir.
I think so far there's none yet. They have not listed yet. There's no specific website that provide the list for this open source. Before, there's in the Philippines we have the philgis.org, I think .net, where they provide all the GIS data for the Philippines. I think they also have rainfall, they have soil there, they have even elevation if you want to study soil erosion, because again, soil elevation or the slope or the characterization of the terrain is also an input for this one. But I don't know what happened to their website. I think the website has been hacked, but so far there's none. So, but you could visit our publications, and in most of our publications, we provide the list or the link, and even the reference or the peer-reviewed articles on the description of the open source database. I hope that I answered that question.
Okay, sir. Thank you so much, sir. Another one from Jeff. I hope this computer application can be incorporated in the curriculum. What is your comment on this, sir?
I don't know. I cannot comment for other SUCs. But in UPLB, we have already have curriculum on this one. Even in 2002, we already have GIS. That's what I presented earlier. My previous professor, Dr. Paring Batan, they have been practicing this simulation models. Even I think even the early 90s. So we have already curriculum in the UPLP. Even in our college, although we are not a college of ag, so we also teach introduction to agriculture, where some of the graduate students, even from the College of Agriculture, enroll. So we teach them this computer applications.
Okay. Thank you, sir. So another question. With your study in climate effects on banana yield in the Philippines, are there now recommendations of varieties and even technologies to our farmers to mitigate its negative effects?
In the terms of varieties, we did not, I did not incorporate the variety because, as you could see in the PSA data, they don't put the variety or specific variety. Most of the data, and I think until the early 2010, you could they just label it banana. But now good thing now they divide it into Lakatan, Saba, and some other varieties. But I provided some recommendation there because there are some, as you could, based on the analysis, there are some areas that where banana is not highly affected by climate, especially on those I think on the southern part of the middle portion of the Philippines. So I think we could reevaluate what are the farmers doing there, so that we could learn, instead of just blaming all the negatives, all the negatives or yield losses to climate. Because I think if there are other farmers of other provinces could or were not like highly affected by climate, I think they're doing something good that other provinces or farmers that other provinces are not, are not doing or not adopting.
Okay, thank you, sir. So I will just fuse the three questions because we have limited time. Now, if we download or if we can download it right now, pwede na ba naming ma-utilize ang mga data for our consumption? Why is it free? Another question, is there already any platform through mobile phones that we can easily access that various digital information? And the other one, I hope you remember the question, sir. And the
Yes,
other one, in QGIS, pwede po ba namin i-overlay ang information, example, soil nutrient, soil erosion, kahit iba-ibang sources ito ng data sets? Yun,
Okay,
sir.
sige. First of all, sa open source. So you could easily download it. You could readily download it and readily use it. And why it is free? I think the scientists realize that we cannot all do the analysis. It's also what I'm mentioning when I give trainings to other SUCs. The University of the Philippines cannot do all the analysis for the entire Philippines. So we also need the help of SUCs, especially those you're the one in the field. For example, you're the one in the Mindanao, so you have more local knowledge compared with those people coming from, for example, coming from Luzon. So you could inject some of your local knowledge on how to approach the problem. For the next one is, ano yung pangalawa? Yung mobile application. Unfortunately, I'm not aware of any mobile application that where you could use it or you could download it. You could download this data because this data sets, it's either they are hosted on the university or where the professor is connected, or they are hosted somewhere online. But it's more on the desktop, not on the mobile platform yet. Then for the last one, the QGIS, I think you could do the overlay. For example, soil nutrient and erosion. Yeah, you could do that as long as your data sets have common coordinate system. What I mean is they are laid out in the same platform or cartographic environment or coordinate system. Then you could do the overlay. You could easily, when you do that you could easily the two maps coming up together. But you have to check again the sources of your data, because sometimes even in the Philippines, sometimes different agencies they use different projection systems. But I think there's also a mandate or a memo that most of the Philippine data sets should be projected to the PRS, the official Philippine projection system, or the PRS 1911, or the Luzon Datum. So if you're getting the data sets in most government agencies, then you could easily overlay it. The problem is when you get the data set from foreign sources, because most of the time they project it, or they put it, or the projection of the map is on the normal or the general latitude longitude system. So, but you could check on YouTube, or you could search on the internet on how to work around with this problem in case you encounter this problem.
Okay, thank you so much for that answer, sir. So this another technical question. What is the ideal number of years that the soil database is reliable for use? Then the other one, there are several systems being used for farmer registration. Example, RCM, RSBSA, FFRS, and others. If in your own view, who should spearhead the consolidation, or can this be incorporated into our national ID system?
Sige. Ma'am, pwede pabalik ng kabilang yung unang first una. Yan.
How many years ideal?
I cannot on this one but hopefully sa Philippines we could update na kasi the last time we were using in college, the last service 1982. I don't know if they have a newer database. Of course, you cannot this could be case to case basis. For example, if the soil is undisturbed, I don't know if there's much more changes in the soil. But of course, if you convert it, then that will be the changes in the properties could happen, and so on and so forth. So I'm not a soil science expert to answer this or to attest for this one, because I think now do still have some of us are still using the old soil survey. Yung next slide, yung next question po. With the ID farming ID system, again, I think I'm not on the authority to comment on this one, but I think we should, if it's possible, we should get at least one number so that you could, for example, I think when I went to the US before, they have yung parang tax identification number, something, social security number. I think and when you go to for example a hospital or a bank, you just give your social security number, and they could extract all the data that if you have insurance, so I think they could just agree with you. They could unify it into one number or in a one database para hindi halo-halo. Kasi later, ang hirap din yan. So, ang dami mong kakausapin, agency eh. Buti pa naman sa atin kung ganun kabilis kumuha ng data. So, we have experience na sobrang hirap kumuha ng data. I have experience before na they won't provide soft copy. So we need to copy the data on their office. So I have to bring two of my RAs. So sabay-sabay kami kumukopy ng data. Kasi ayaw nila ipalabas kahit ayaw nila ipasirox, ayaw nila ipal. So there's a lot of problem. Hopefully ngayon wala nang gano'n.
Okay, that's exactly, sir. No, unification of everything. There are so many ideas we have right now. But anyway, there's no question raised, sir. Thank you so much, no, for your spending time and your sharing your expertise. At this point in time, I would like to read the certificate of appreciation to Dr. Salvacion. Certificate of appreciation is presented to Dr. Arnold R. Salvacion for sharing his expertise and knowledge in his paper entitled Open Data and Tools for Agricultural System Analysis, given this 23rd day of July 2022 during the second International PAA Virtual Congress and 2022 Philippine Agriculturist Summit. Signed, Roberto F. Ranula Jr., the Board of Trustees Chairman. Signed, Lowe A. Divina Gracia, PAA National President. A big hand for Dr. Salvacion.
Thank you po, thank you.
Okay,
So,
salamat kaayo, sir.
Thank you po. Doon pala sa nagtanong po na I am open for consideration. Just send me an email. I think I have my email. So if you have further questions that were not answered during this presentation, you could easily email me, and I'll try to attend to your questions. Salamat po. Thank you.
Okay, thank you so much, sir. At this point in time, I would like to have a brief summary of what has been done for the second plenary session. Now, my dear agriculturists, with the second plenary, we gained information, technologies which we can apply in our work, such as digital agriculture, farm clustering with RCM. We have also discussed agriculture hub, the agriculture 4.0, and finally the open data tools. No, so we hope that we can make out of it our services accurately and easier to our farmers. At this point in time, I would like to thank our participants, the administrators, and everything for listening and participating in this discussion. I will now turn over to our Master of Ceremony, Dr. J and Dr. Mon. Sir and ma'am, please.
Of your session.
At salamat din po sa lahat ng nag-post ng questions nila para sa ating tatlong speakers. This really made our discussions this morning more lively and more informative. Mamayang hapon po ulit, sana po ganun ulit kayo ka-interactive. Okay?
Okay, so again, thank you to all our plenary speakers, the Project Intera, Dr. Roger Concepcion, my good friend, Dr. Glenn Gregorio, and Dr. Salvacion. Now, before we go on our lunch break, I would like to make a very clear announcement. And hopefully this will already resolve all the inquiries and comments that are being posted in the StreamYard. So, participants, please listen carefully to these announcements because we will no longer answer queries from the Facebook StreamYard or your emails. Okay. First item. The first item is about the inquiry of members who have paid the registration fee twice, meaning to say they have sent their payment, registration for the conference, registration for the conference, and then when they registered in the portal, they also again paid for the conference. Now we will be verifying the data of whether you have paid twice, and then we will, if we were able to validate it, we will refund your registration fee through GCash. Okay, through GCash. Okay. Now, next announcement is on the evaluation. We will be posting again the link for the day two registration, evaluation, in consideration of the request of the others who were not able to fill up because of the sudden, when we ended the session abruptly. Okay, so later on, our moderator will post the link for the day two evaluation. As regards the evaluation for this day three evaluation, it will be posted after our closing ceremonies. Again, it will be posted after the closing ceremonies. Kaya walang maghahanap ng evaluation during the period that we're still, the conference is ongoing. And the third item, and the certificates. Okay, ito, makinig ha, kasi marami itong kan. For members who have paid and registered through the portal, okay, again, members who have paid and registered through the portal, you can view your certificates at the portal, and there will be two types of certificates. One is the certificate with the CPD units, and one with the CPD certificate of participation. You can view it at the portal and you can print it, and also that will be emailed. The link for the certificates will be emailed it to you. So ibig sabihin, dalawang modes nyo pwedeng makuha yung certificate nyo of with CPD points and for participation through the portal and through the email that will be sent to you. Again, this is for members who have paid and registered through the portal. Now, for members who did not pay for the registration of the conference but are registered in the portal, meaning to say you are in the portal, but for this particular conference you did not pay, you can only get your certificate of participation. You can view it and print it in from the portal, but you will only get certificate of participation, no CPD points. That's very clear. No CPD points for members who have not paid the registration fee for this particular Congress. Okay, so we are finished with the members. For non-members who have paid and registered for this conference, you will be given or you will receive two types of certificates through email. Okay, through email. It will be sent to you through email. One is the certificate with the CPD units, and the other one, your certificate of participation. Okay, so that is for non-members who have paid for the registration. For those non-members who did not pay but registered for the event, you will only get your certificate of participation that will be sent to you through your email. So I guess the certificates are clear on how you will receive your certificates with CPD units and certificate of participation depending on the status of your membership and depending on the status of your payment for this Congress. Now, the next item is on the attendance. Napakakulit. Ang daming makukulit dito regarding the attendance link. The attendance link for day 1 and day 2 will no longer be posted because that is already done. What we will be posting, and upon my instruction to our moderator, will be the attendance link for day 3 for this day. Okay? Remember that we are getting the attendance for both morning and afternoon session. So the attendance link will be posted as in 10 seconds. So we'll have a countdown. Dax 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, post. Okay. So you can start registering your attendance for this AM session. Okay. Thank you very much. And see you this afternoon. Enjoy your lunch. Again, we would like to thank our partners for this Congress, the Philippine Council for Agriculture, Aquatic and Natural Resources Sustainable Development, or PICARD, Leads Agri, HIPRA, SHERCA, and Nature Tech. Thank you very much, and have a fruitful and palatable lunch.
Good afternoon, everybody. We will be ending the stream at 12 noon. Kindly take note of the link for the attendance. And please join us for the afternoon session on the same Facebook group and on YouTube. Thank you and have a good lunch. For the benefit of those who were unable to fill up, we are now flashing the Day 2 evaluation form. This is the Day 2 evaluation form. Kindly fill it up. Kindly copy it onto your respective browsers. We will be extending the stream for a few more minutes to accommodate the copying of these links. Thank you. We would like to thank our partners, the OSTP Car, Leads Agri, our major sponsor, Nature Tech, and our sponsors, HIPRA and Circa.